സംസാരിക്കാമെങ്കിൽ അതായാലും
എനിക്ക് ചിലപ്പോൾ നോക്കേണ്ടി വരും.
അപ്പോൾ ഞാൻ അവിടെ നിൽക്കുന്നതിന് സൗകര്യം.
Welcome back. I hope you enjoyed the short break. We, Trippi Department, FISAT is extremely happy and proud to conduct our international conference on smart technologies for power and renewable energy SPECon. We are indeed fortunate enough to have eminent scholars with great experience and exposure in this area. With great happiness, we welcome all the speakers for the day and all the delegates from Germany, India and other parts of the world to this 3-day international conference. Starting with the first session, introducing the keynote speaker. Today, we have an eminent personality, Mr. Anish S., Deputy General Manager, Cochin Shipyard Strategic and Advanced Solution at CSR, to deliver keynote lecture on the topic Smart and Sustainable Technologies for Marine Electrification. Mr. Anish S. received BTech from CET Trivandrum. He also received postgraduate diploma in power plant instrumentation and control from Annamalai University. He received Master of Science from BITS Pilani and MBA in project management from Bharatiya University. He is the team lead of Cochin Shipyard Strategic and Advanced Solutions and also a member of R&D cell. He is specialized in exploring maritime solutions, smart ships, unmanned systems, data analytics. He has experience in system integration, integrated platform management systems, ship data networks, C4I, electronic warfare, integrated bridge systems, underwater sensors. He was a recipient of Chairman's Award by CSR. We all heartily welcome you, sir, for delivering this session.
Yeah, okay. Yeah, good morning everyone. Thank you for giving me an opportunity to explain the scenario of smart and sustainable technologies. So today we are in SPECon discussing about smart and sustainable technologies. I will be actually talking about the various aspects with respect to the maritime segment. Most of you may not be aware. So I'll keep it very introductory so that this will give you an inspiration for you to look forward, and probably we can also associate as organization in the long future. So I'll start with, these are the contents, what I'm planning to do today. So I will first give a glance of Cochin Shipyard Limited, most of you may not be aware. Second, I will look for the maritime smart technologies and then sustainability enablers. Then I will also look into the various grid configuration which is available on the ship, and then I will also explain some of the live examples of Cochin Shipyard working on the green technology. So first I will explain about Cochin Shipyard Limited. We are the largest shipyard in the world, in India, with a global quality and proven track record. We have got an experienced leadership and a young task force, and we have a global footprint with respect to the delivery of ships to various countries including Bahamas, Norway, USA, UAE, Middle East and Europe, and we have got 7 pan-India facilities. So we are headquarters in CSL Kochi, and then we have got other units in Mumbai, Kolkata, Port Blair, and then we have also 2 subsidiaries, one in Kolkata as well as in Malpe. Okay, now I will just give an introduction to the Shipping 4.0, which was inspired from Industry 4.0. So the key elements in that is robotics, cybersecurity, system integration, Internet of Things for sea, data analytics, cybersecurity, and simulation, and augmented reality, including AR, VR. So these are the key things. So with respect to the present seminar, the key things what we are focusing with respect to the new technology what we are trying to implement in the ship are electrification, digitalization and connectivity. Earlier these things were not given so much importance, but right now we are focusing on these things because this is going to bring the complete hardware and the software to work very correlated, so that we can have a methodology, and we will also, this will also disrupt the way in which we will imagine how vessels will move in the sea. So first concept what I wanted to propose is on the smart vessels. I will just showcase on the screen. So we will, So we will have normally as the ship goes into the sea, beyond the line of sight communication, it uses satellite for communicating the data, because it is impossible for the cellular network or the normal VHF, UHF or the radio frequency communication to connect with the ship. So we will have to rely on satellite based systems, for which cost is very huge, and also hello. Okay. So we will have to use satellite based communication to connect with the ship, and then we will have a data center similar to a remote control station which is available on the shore. So we will so when we do this, we will have IoT sensors which is connected at the various system parameters, and it will capture everything, and through the satellite or when it's coming to the port, it will be synchronized with the data which is available on the remote control center. So in the remote control center, you will be in a position to create a mathematical model of the existing ship systems here. Maybe you will have a mathematical model of propulsion system, means a motor, the controller for the motor, and propeller, steering gear, every systems, our navigation systems. We will have a mathematical model running on this remote control center, and we will be in a position to do predictive, preventive analysis, or we can even predict when a subsystem is going to fail and do the needful, so that we can get the spares upfront. All those things can be done with this methodology. So in adding to what we are saying is that we will have a 360 view of the complete maritime data, means all the data which is captured by the IoT will be made available seamlessly to all the stakeholders. Means when you are doing the ship, you will have the ship will have statutory operation. There will be a ship operator, there will be regulatory bodies, there will be customer connect and insurance. All these people will be in a position to view this data through the aggregation of the data via the IoT technology, and then this data can be seamlessly and synchronously seen by all the stakeholders to take the necessary corrective action or the decision support. So extending that decision support, we will use advanced machine learning as well as deep learning. We have not started using it, but other countries like Singapore, ABB is using this. There is a reference center in Singapore where they are using this methodology to advance prediction of failures, which we are planning to in future use in our country also. So for which what we are actually doing is that as a pilot project, we are doing some projects where we will be in a position to capture the relevant data and then do some small mathematical models and some CNN models through which we will be in a position to predict this. All these indigenous technologies we are trying to develop, which we are doing in-house or with some strategic partners. So why I am trying to say all these things is that as a student community, you have to understand that in future, even though you are from an electronics, I am also an electrical EEE from CET. What has happened over the years is that we have been working on computationally or software intensive systems. It is so unless or until you don't have a proper vision of a cross discipline, which includes the collaboration of mechanical data as well as understanding of the software systems which is going to control these controllers, the control technology, all those things you should have a fair understanding before you are going to start working on these kind of systems. So if you think that only by keeping your domain restricted to electronics or power electronics or to electrical related field, you will not be in a position to scale to the next level. You have to have an open understanding of cross relation of these disciplines. So please keep it in mind and please ensure that you read wide as you go or as you move through your semesters. It is not about amassing the knowledge and dumping it onto the papers, but beyond that you should retain it so that you can maintain those things as you, because frankly I'll tell you, I was least bothered about instrumentation systems on board, and I used to bunk those classes when I was in CAT. But what we can say is that karma made me do the complete instrumentation and control for the aircraft carrier. I was the single point contact for the complete control and monitoring system for the aircraft carrier, which I am really proud now. But the point was that at that time, had I given more importance to the wider reading which was described to me by my those time gurus, which I conveniently didn't care. So please keep those things in your mind. Because I am saying from that experience, because I had to struggle a lot in understanding those concepts, and fortunately we were in a position to do that. So this is one important thing which you have to understand. This is going to change the way the industry is going to see everything. So you may be hearing digital twin of the late. What is in simple sense is that digital twin means you have to create a simplified, computationally possible mathematical model. It's very important to understand these aspects. It has to be computationally possible. You create a mathematical model with such a granularity. If you increase the granularity, the computational possibility may not exist. So you have to understand that it has to be simple. It has to be computationally possible in the edge devices. Edge devices are the devices which are going to run on these IoT related technology. So if those things can run those mathematically simplified mathematical model, you can create the exact potential or the exact device to a real world situation, so that you can exactly predict it, or you can visualize it, or you can even extrapolate it, or if you want to scale a motor to the next level, you can do all those. Possibilities are there. So please keep this in mind. This is only possible if you understand data science, you understand the possibilities of mathematical possibilities or statistics, including correlation, regression. All those things are very critical. You have to use some tools like Octave or MATLAB. I will always recommend understand Octave, because the open source is a very critical thing. You will be easy, it is very easy to do it with MATLAB, but the point is that you exactly don't know what is going to run inside. In Octave, you will exactly know what is going to run, and you will have a control on source code, which is a very critical element as we go for a commercial solution, because it has an element of cyber security. You exactly don't know what code is going to run there, and tomorrow you install this on a very critical asset of defense application. If there is a problem in cyber security in future, it is possible to reverse it is possible to neutralize with a single key shot. So please understand the value of the data as well as the mathematical model and the source code. So it's a very critical aspect. Please, as students, keep it in mind. It's a very, I would say, humble request. Please keep it in mind. This I am saying from my personal experience. This is another concept. You have to understand the difference between autonomous and automation. Automation means you are creating a procedure so that it works on that procedure. But with respect to the autonomous system, it will understand the situation and it will do a decision support. Those clarity of thought has to be maintained, because people will say that I am automating a system. Automating a system doesn't mean that it is an autonomous system. Autonomous system means it can understand the situation, but those understanding of the situation can be through some statistical model or through some mathematical model. It can even be through a lookup table. So it depends on how you are going to make that system situation aware, or it perceives what is happening. Right now I am able to perceive a lot of people sitting here, a lot of people are talking, a lot of people are listening. So this is the situation awareness what I am presently perceiving. So that is an autonomous way of doing the things. But when you do for automation means it is a predefined way. You describe the system, you create the behavior, it has got a behavior, it will work as that. It doesn't have any situation awareness, it will go as prepared. So please understand the difference. So these are the key smart technologies what we have understood and what is right now powering the industry 4.0, because my topic is about, first part was about smart and second part is about sustainable solution. We will have to combine both the solution in creating microgrids within the ship. So from the first part was about making you people understand the key concept which will be used with respect to the smart technologies for using on board the ship. Now I am moving to the sustainable part of it. So sustainable part means we have to talk globally. We have to understand the effect of greenhouse gas effects. We have to understand what is causing the pollution at a global level, how we can reduce the greenhouse gas, how we can do in a smarter way. So in order to do that, we have to understand what are the methods by which we can go for greener fuels or we can go for renewable energy resources. So these are the potential renewable energy resources which we are targeting on the maritime segment. One is hydrogen, second is ammonia, LNG, LPG, methanol, then we are using renewable energy like wind and solar. We have not considered other things because we have mainly considered a mobile platform, because considering the geothermal and other wind is possible, but we have not considered that fully. So first and the most critical element which is going to be there for a sustainable energy resource is energy storage components, which can be supercapacitors or ultra capacitors. Then there can be batteries, or we can use something like a flywheel. What I am trying to tell you is that tomorrow if I am supposed to create a UPS of around 800 kW or 1 megawatt, is it practically possible to create a 1 megawatt UPS with battery? Practically it is possible, but just imagine the requirement of, it is possible that I can create an UPS with 1 megawatt. The main calculation will be to deliver 1 megawatt for how much time. So let's assume that I need only 1 megawatt for a period of 20 to 30 seconds. Will I create a full UPS with batteries? It will be it is technically possible. The challenge is that it will be a heavy solution, maintenance will be heavy and huge. For those situations, typically in data centers, we use something known as a flywheel, for which you are converting that momentum into that kinetic energy, so that for a period of 10 to 20 seconds, we can start a generator, which is running by hydrogen or by some renewable resources, so that the solution can be simpler and it is manageable. So please understand that what is right now happening is that these technologies of energy storage components, which is getting used in the land or in other application, we are in the similar manner, like for the AI, we are doing something known as transfer learning. In the similar manner, we are going to use these technologies to suitably adapt into our maritime segment. But the challenge is that it has to work on harsh environment. Second thing is that it has to be, the weight versus power ratio has to be very high, because we cannot afford to have huge weights on the ship, because it will sink. And we will have space limitations also. So those are the other consideration which we need to consider when we are going for a ship-based solution. So we are right now using supercapacitors, batteries and flywheels. Please understand, because these are the technologies right now it is happening. Everybody is now going after lithium batteries. How many of you know that there are sodium batteries, calcium batteries being used? There are some, aluminum batteries also being used. Maybe people are not aware. So please open up your eyes, browse through the internet for these kind of things, because these are the technologies in which you are going to work if you are going to be retained in the core field. So considering, I'm extending it to the battery calculation. How do we do a battery sizing for a ship? We will take into consideration what is the total installed capacity, what is going to be the operating profile of the ship, whether it is going to be a continuous thing or whether it is going to be used for a small time, or where it is possible to charge and then again use it for some time. And we will also take into consideration the user requirement. Then only we will talk about the battery chemistries. So in the next slide you will understand that for the maritime batteries, three technologies right now we are considering. One is known as the NMC technology. Then we have a lithium phosphate battery and the lithium titan oxide battery. So the different consideration from the specific energy, the charging C rates, the safety perspective, the lifespan and the cost is being shown here. What I wanted to make you understand is that these considerations are taken into account for these aspects. So tomorrow, if we are going to decide this, we need to understand the application properly. It is not a single shot solution. You take a lithium ion or lithium iron phosphate battery and just put it onto any solution. It is not possible. You have to, so that is where you have to understand the operating profile. In order to understand the operating profile, you have to understand how the user is using that ship currently. So that it right now, since it is a generator, you have no botheration with respect to energy, because you fill the fuel tank, it can run forever. But it is not the case with battery. So if you see here, specifically with respect to the charging time, you see the charging rate of lithium LTO batteries are very high. Means like in the what I can say with respect to our water metro, it can charge to full capacity in 15 minutes. But if you take LFP, it cannot be charged at that level. So if I use a LFP battery, I will take more time. That is the reason why our cars is taking more time. So, but if you see with respect to the two-wheelers, specifically they are looking for NMC. But the challenge with NMC is this. The safety is highest in LTO. See here, NMC is not that safe. That is the reason why you are seeing lot of accidents happening there when you do the charging beyond the limits, and when the battery management system misbehaves. These are the critical aspects what we need to take into consideration. So without understanding this, if you apply it to any of the solution, it will not work. So you have to understand user requirement also. Say, for example, it is working on a highly corrosive environment, you cannot use the lithium batteries. That is the reason why they are using calcium-based batteries. Please have a look at it, because these things normally don't come in the literature unless or until you don't search it. So please understand these technologies. It's very critical as you go in your studies. So this is another technology which we are using. I will request everyone to please see this ship. This ship is known as Energy Observer. It came to Kochi. Please note this ship because it is a research vessel where it is showcasing a lot of technology, whatever technology is possible, renewable on a ship. It generates on the go hydrogen. It uses that hydrogen to power itself. It has got solar panels on all sides. It can charge by itself. It is not taking, it is a net zero ship, means it doesn't take any energy from outside. Please go through the website of this ship. It is known as Energy Observer. It's an R&D ship. The challenge is that you cannot scale it to the bigger ships because of various problems which I will request you to understand, because understanding the problem is very critical. You start from first principle, understand the problem from the user perspective, and then try to apply the technologies which is possible, because there is a lot of technologies. People will say that it is practically possible to put solar panels everywhere in the ship and you can drive it. It is not possible. Please understand. It will not generate, because I am seeing from if somebody can come to shipyard, you will see that how much energy it is creating in each cell. We can show you. It will not create. And in order to run the ship, the energy curve or the energy, the kW versus the speed which is going to come, it's not a linear curve. Means you pump in on the shaft 10 kW, ship will go at say for example 5 kilometers per hour. In order to reach 7 kilometers per hour, it is not double. It is based on a quadratic equation, like an exponential equation. You will require that much amount of power to increase the speed for the vessel. So in order to generate that much amount of energy, you have to store that energy. You cannot on the live take the solar power and directly drive it to shaft. It will support you, it will augment you the primary source, but please understand you will definitely require a energy storage component to ensure that it is happening. So whenever people are talking about fuel cell, whenever people are talking about solar cell or any other wind assisted part, everything, there is going to be an energy storage component which is going to help you, because regarding the dynamic characteristics of the solar cell, because wind or solar, it is highly dynamic. So the response of these things are not that good. So it has to be compensated by a energy storage, because batteries, flywheels and ultra capacitors, the response time is very fast. But it will not remain for that much time also, but that also you need to understand. Now this is another technology which right now everybody is after it. People are talking about hydrogen fuel cell, hydrogen engines, hydrogen carriers. So this technology is there for from 1800s onwards, but people were not using. There is a company here, TCCL, Travancore Chemicals, which is creating hydrogen for a long time, for the last 20-25 years. But the point is that this hydrogen fuel cell, there are different technologies for creating a hydrogen fuel cell. Right now we have used a hydrogen fuel cell which is based on low temperature proton exchange membrane, which requires a high purity hydrogen, that is 99.9999. That purity hydrogen availability is only possible using special methods including electrolysis. So the challenge for that hydrogen to be used on a car or anywhere is that you require that hydrogen. So in order to prepare that hydrogen, you will require those extensive methods for doing that. So I will make you understand, this is for the academic understanding how it is operating on a hydrogen fuel cell. we will require a hydrogen as well as air, because the process is very simple. You have to mix hydrogen and oxygen, it will create water, it will create some heat, and it will create some electrons. That is the process. So if you see here, you will have a hydrogen tank, you will have a pressure regulator, because hydrogen, because the fuel tank, you will require hydrogen to be compressed in order to create that much amount of energy. So you will require that hydrogen pressure to be reduced to the workable limits, that is around 1 bar. You will reduce it, and you will ensure that there is no moisture, and then you go it through a humidifier to remove the air, remove the water content, and then it goes to a fuel stack. So the hydrogen as well as the air, it goes to a fuel stack. When it is combining, it will just generate the electricity, and it will create the heat. In order to cool the heat, you will require a system to ensure that you are cooling the fuel cell stack, for which this circuit is required. So what are the technologies? Why I am focusing more on hydrogen fuel cell is that right now a lot of thrust is given on hydrogen and hydrogen based things. What are the carriers, energy carriers which we can use along with hydrogen are ammonia and methanol are the key things what right now in our shipping industry we are using. So what are the methods by which you can control the fuel cell? One is the voltage control, current control, then pressure control, and the temperature control. What I will do is that when I am explaining that onboard grid of our vessel, I will explain that in detail. So finally, so I have make you understand what are the smart technology, what are the greener or the sustainable technologies. Now we have to also understand, when we look into the maritime sector, one is the ships and second one is the port, because it is the area where port and the ship will constitute the entire maritime segment, for which we will require a smart charging devices which will charge the ship, or probably you can use a bigger ship with hydrogen powered or something, you can give it back to the grid also. So there are different methods people are using. So we are very fortunate that we are at the equator. We have a higher probability of solar power available across the season, so we are not really bothered. There are areas which are highly remote, where you cannot take the electricity, for which they are using ships for powering the entire city. Bigger generators are being used in the ship, and the ship is going there and power the. So those ships now can be converted to a hydrogen based solution or an LNG based solution, and then they can also be used for powering the grid. So what are the, in the smart grid integration, what are the main thing? One is the smart energy management. Smart energy management is a very simple concept but very, very difficult to implement. You have to understand in the static as well as the dynamic aspect, what is the power demand required and how we are going to, what is the consumption versus the demand. So this has to be mapped using suitable techniques. We are using very fast, because the challenge is that the understanding of the dynamicity of the alternators, and when it is working on parallelism in AC as well as in DC are very, very different. You have to understand that controlling a DC grid is very simple, but AC grid is very, very, very difficult. So it requires ultra fast controllers. You cannot use a normal PLC or a normal controller to ensure to enable a closed loop. It requires a dedicated controller with fast acting ADCs to understand the exact demand on the bus and to generate those amount of things by controlling the voltage as well as the power. Using the prime mover control, you can control the speed of the governor, and I am talking from the generator perspective. But those generator can be tomorrow driven by hydrogen or LNG. You have to control the speed as well as, so that that speed control and the voltage control has to be precisely executed, or else you will not be in a position to exactly understand the demand versus the output of on the BESS. So same way, integrating the solar panels. Integrating the solar panels, as I have indicated, you cannot simply connect to a DC grid some solar panel. You will require some MPPT controllers, you will require some DC-DC converters to ensure that the voltages are within the limits of the buses, and also you will also require an energy storage device. Without that, what happens is that you will have to store that energy, or else you will have to consume it that way. But anyway, you will require the integration of solar panel or wind turbines or the fuel cell. You will require an energy storage device, because what happens is that in a fuel cell, the response for the dynamic load is very, very slow. What happens is that if you are taking a fuel cell, even though people are saying that right now the vehicle or the car or the bus or the ship is powered by fuel cell, it will require a response. The dynamic response of the fuel cell is very, very slow. You will require an energy storage component also in that. So what ideally means is that you will have a hybrid configuration on board to address the dynamic part, and for the normal constant power requirement you can safely use the fuel cell. So you will require, what I meant was that whatever may be, it can be a solar cell, wind turbine or fuel cell, you will require an energy storage component. Without, people will say that I am running this vehicle or bus with fuel cell alone. It will not, because what happens is that in order to handle the peaky loads or the dynamicity of the loads, you will require an energy storage component. It can be even hybrid capacitors, ultra capacitors or battery, which will support you during that time, that peaky load, so that when it gets stabilized, it will be handled by the fuel cell, or it can be handled by the solar panel. So the key aspects is efficiency, reliability and sustainability. So now I will go to the various terminologies which we have seen over the ship. First one is a multi-voltage topology. Here, if you see here, there are two voltage buses, 1 volt, these are the two buses. We have this is going to be a DC bus, even though this, the generation is on AC, this is converted to DC, and this is used for the heavy loads, if you see here. And the normal loads are done using a separate voltage bus, which is done through a DC-DC converter, and it is powered to these things. This is one method which we are using in a multi-voltage bus topology. This can be an architecture where we have been using a AC bus. If you see here, the entire bus is an AC, so that you can connect the generators directly. So this is going to be a constant frequency bus. Wherever we are using a battery or a fuel cell, this is the symbol for a fuel cell, this one. So if you are using a fuel cell or a battery, you will require a DC-DC conversion and a DC-AC conversion to ensure that you are matching the bus voltage. And whenever you are using an AC load, accordingly you will have a reverse conversion. So the DC grid implementation is far simpler, but if you are using a AC generators, you will require a AC to DC conversion to do that. All the other thing will only require a DC-DC converters. But these are the typical things we have seen in the normal ships, where you will have generators running on an AC bus. Then through some converters and fuel cell, we are converting it to a DC grid that will be at a different voltage, and then we will ensure that based on the load demand, you will see that why there is generators as well as fuel cell. So for each load application, in order to ensure that we are driving it at the maximum efficiency of those devices, we will be using this methodology. So coming to the, this is the one slide what I wanted to explain more. This is a single line diagram for the hydrogen fuel cell vessel which we have constructed in Cochin shipyard. So this one, we have a fuel cell with 4 stacks. This fuel cell is generating a DC voltage, and it is generating around 50 kW. We have two batteries with a bus coupler on a DC bus, and then through that we have the propellers are motors are running on induction motor. So you will require two DC to AC converters, and then for doing all the AC and the DC loads on the ship, you have some inverters. So here what happens is that you see that the batteries are directly connected to the DC bus. So the only element by which you can charge or the discharge is that you have to control the voltage of the fuel cell. So that is the point. So I will once again explain, because you have to understand it's a very simple thing, but you have to understand, since the batteries are directly connected to the grid, only element you can control is controlling the output voltage of the fuel cell. So you increase the voltage, you can charge the battery. If you in order to discharge the battery, typically what happens is that you will have to maintain the voltage slightly low, and so that you can ensure that both the batteries as well as the fuel cell is powering the load. So now I will as I have explained the smart part as well as the sustainable part, we will see some live examples of the vessels which we have delivered recently. One is an ASCO barge which we have delivered to Norway. This is a pure battery vessel, and this is going to be one of the autonomous vessel which is going to drive in the Norway. We have constructed and we have done it, delivered it as a battery vessel. The autonomy trials are right now happening in Norway. So this vessel, if you see, it is termed as an autonomous vessel, but it is going to operate between just like our ferries, between a point A to point B it is going to travel. So it's a very simple autonomy, means point A to point B it will do an autonomous travel, and it will do that collision avoidance, and it will find the path between A and B. So this is happening in Norway right now. And this is the, as Regis sir indicated, this is the solution what we have given for the urban mobility through the water metro. Ultimately, this is going to be powered by green electricity through solar grid. That is what we are made to understand, because ultimately it really matters is that if it is not from the grid, again we are relying on fossil fuels. So we have to ultimately go for a solar or other renewable based solution. This is also a battery based vessel, but since there was a requirement for the emergency control, we have put a generator also on board. So in case the battery fails, we can start the generator and use it. This is a hydrogen fuel cell vessel which I have indicated. Even though I have indicated a 6 kW solar planet, it is going to it is giving me around 2 to 3 kW only. We have checked on our trials. So that's what I was trying to explain. What I can say with proud is that the entire control philosophy we have wrote it, my team only wrote it, so we don't have to depend on any other people for creating these kind of vessels. So this is what, that's why we have written it as a completely homegrown technology. So here what we have done is that we have done a kind of a transfer learning. I don't know how many of you people know a company known as KPIT. It's a company which produces this one. It is a automobile company which creates unmanned cars and also create EV solutions. What we have taken is that we have taken the powertrain solution, the motors, controllers from them. We have along with them marinized so that this can be used on the maritime use case. And the complete control philosophy was developed together, and they have coded it, and we have done extensive testing there. So right now it is getting tested at our place. And this is another vessel. This is going to be used along with the wind farm vessels in Europe. This is going to run on methanol, which engine is being developed at Aurangabad plant of MAN. So this is another vessel which we are right now constructing. And this is another vessel, we are already in the construction phase, and this is going to be running at Varanasi and other place. It is similar to the water metro only. And the last one is this is another bigger, if you see the fuel cell capacity is around 1200 kW, means we are using cryogenic hydrogen for powering this thing. So it's a very highly niche technology, and hydrogen is, you have to understand, is highly inflammable. You cannot see the hydrogen when it is burning, you can only feel it. You can see it only in the IR, or even in the daylight it is impossible. In the evening you can see it in a very small thing, but you can only feel it via heat. So even though, you will be thinking why still you are going after hydrogen, is that it is the same case as right now you are traveling on the aircraft, same thing. So ultimately we have to bother about the greenhouse gas emission, and we have to understand it properly and find a solution so that we are contributing our part to mitigate it or reduce it. Thank you.
Thank you so Thank you so much, sir, for this informative session. Now the session is open for queries.
Yes. Yes. I can explain these. Hello. It is completely developed in India. Means the propulsion motor, propulsion drive, batteries are from Exide. The complete hydrogen fuel cell from individual stack is from India. India.
From India.
Fully is from India. Only thing what is coming from outside are those controllers, because anyway microcontroller and microprocessor we cannot make. So other things it is fully from India.
So what about the life of this fuel cell, hydrogen fuel cell?
The fuel cell life is around 8,500 hours. That is being estimated right now.
Okay.
We are doing that modeling right now with the, that model is now getting reflected as we do the trials. We are doing a 100 hours trial in Cochin, and then it will finally go to Varanasi. That is the idea.
So on an average, how many years it may last?
Typically 3 years, 4 years is the minimum thing what we are seeing. But before that the battery will go, because batteries are LFP, which is going to last for 2,500 charge. So you have to change it.
Any more queries?
Yes.
How about the pressure in your storage?
Okay. This vessel, if you are referring,
This one?
this one is the vehicle which we have created. It is running on 350 bar. 350 bar pressure. We are holding around 40 kgs for 8-hour operation. 40 kgs.
Okay.
But this one is on a cryogenic thing, where we are holding it on, I think it is on that cryogenic part, and the pressure is, I think, on 350, I'm not sure, I have to check.
Okay.
But
Okay.
this is on a cryogenic thing, but this one is on a gaseous thing. We are holding at 350 bar. Because we have a limit which is put by the PESO, or the safety authority, to go not beyond 350.
Okay, because
In China it is 700 bar.
sometimes you have also in Europe, so 700 bar.
We are not cleared for that.
Okay.
For the research it is cleared, but for operation it is not cleared. So for the safety purpose we are using only 200 bar, because the challenge is that to make the people understand. So what happened even within the shipyard, when we filled the hydrogen, people were very reluctant to come in, because then we asked them, we have cylinders of argon and other gas inside the yard, you are not bothered. Then people slowly understood, and right now people are understanding. So it is not easy, that regulatory part is coming only, so people
Okay.
are getting used to it.
And how about the control of the system? You do it by yourself?
Yes, which control you are asking?
So I mean the control of the complete hydrogen system?
You mean hydrogen system? This one is
This one, yeah.
This one control is within the ship.
Okay.
Because what we do is that we have cylinders which is kept at 350 bar in the ship.
Okay.
So what we do is that we will require, there is a filling facility there. We use storage, and then we use a pressure distribution method. So we will bring a vehicle, and through that vehicle only we will put the hydrogen inside the ship.
And what's the origin of the hydrogen?
Those hydrogen right now what we are getting is not green right now.
It's made from natural gas.
Yes,
Okay,
right now it is made from natural gas, but the ultimate intent is that when this vehicle is going to operate on Varanasi, what we are requesting, what we are made to understand is that it will be run from green, because there are some electrolyzer plant being developed there. Yeah. Yeah.
Any more queries? Now I invite Session Chair Dr. Parvati R, Professor, Electrical and Electronics Engineering Department, FISAT, to deliver the vote of thanks. Good morning. I am happy that we have Mr. Anish S. from Cochin Shipyard Limited for the keynote session, for the first keynote session of the second international conference. And he mentioned many points that were not a consideration in the vessel design in earlier days. And we find that the sustainable and smart solutions will have a positive impact on decarbonization also. And he highlighted the importance of interdisciplinary knowledge to expand the career in future. He mentioned about the smart electrification solutions being used in the marine environment these days. I thank Mr. Anish S. for the wonderful session that he handled now, and it was very informative. Thank you, sir. As a token of our love and gratitude, we would like to present a certificate to Mr. Anish S. Sir, please come forward to receive this certificate. Ma'am, please do the honor. Thank you, ma'am. It is indeed my pleasure to welcome the next speaker of our session, Dr. Biju K, Assistant Director, APJ Abdul Kalam Technological University and Secretary of IEEE Kerala Session, and Session Chair, Dr. Ulswald, Professor from Germany. Dr. Biju K received the BTech degree in Electrical and Electronics Engineering from the Government Rajiv Gandhi Institute of Technology, Kottayam, an MTech degree from NIT Calicut and PhD from NIT Calicut. He is currently working as the Assistant Professor at APJ Abdul Kalam Technological University, Kerala. Formerly, he was working as the head of the Department of Electrical and Electronics Engineering in College of Engineering, Mona. He has got more than 20 years of teaching experience in various engineering colleges across Kerala. He is a member of Board of Studies and approved research supervisor of APJ Abdul Kalam Technological University. He has delivered various technical talks in different engineering colleges. He is a senior member of IEEE and currently the Secretary of IEEE Kerala Section. He was the General Chair of the International Conference IEEE Plus GUI 2023. He has served as Technical Program Committee member in many IEEE international conferences. He has also chaired technical sessions. He has published a number of papers in various international journals and conferences. His research interests include power electronic converters, control checkers, power electronic converters for renewable energy technologies, power electronic converters for electric vehicles. We are extremely privileged to have you, sir, to deliver the keynote lecture on the topic power converters for electric vehicles.
Yeah. So good afternoon all, and welcome to my session on power converters for electric vehicles. So in my talk, I will be addressing, before coming to the various power converters used for electric vehicles, I will have a quick review on the various types of motors being used for electric vehicles, because the type of converter used for electric vehicles depends largely on the type of motor being used for the drive. So in this talk I will be addressing the type of motors before, and again going before to the power converters, we should understand the various types of power semiconductor devices. So I will be briefly touching on the various types of power semiconductor devices, then various chargers, on-board chargers, off-board chargers, then various wireless charging systems also, then EV traction system, BMS also. In all these topics, I would like to give you a brief idea, an overview. I won't be going to the detail of each topic because that may not be possible in a brief session. So we know the power electronics technology has helped a lot in improving the efficiency of the electric vehicles. And in charging also, the various kinds of chargers being developed, a big thanks to the latest developments in power electronics technology. And the battery, even wireless charging technologies also, the power electronics has played a big role. And we know the various types of motors include basically the AC motors and DC motors. And I hope you might be aware of induction motor, synchronous motor. The type of AC motors being used in EVs basically or majorly contributes to induction motors and permanent synchronous motors. Earlier it started with induction motors, but we know the PMSM has better characteristics than an induction motor. So nowadays induction motors are being gradually replaced with PMSM motors. But when the motor is a DC motor, we know basically the separately excited DC motor is another option. Or even for small vehicles like two-wheelers or even auto rickshaw, BLDC motors is preferred because of multiple reasons. So I'm not going to the details because you are well versed with, I hope you are well versed with the machine part. So traditional DC motors include, we know, the separately excited DC motor, which is a common DC motor being used, and we know the characteristics of this motor. And the AC motor, we know the DC motor is more easy to control compared to an AC motor. But nowadays we can easily control AC motor also thanks to the latest development in power electronics technology. So we can have variable frequency. You might have studied the vector control. Variable voltage, V by F control, etc. So nowadays, or FOC is the field oriented control, DTC direct control. So with these technologies, we can now easily control the speed of induction motor or permanent synchronous motor. Yeah. Okay, yeah, permanent and synchronous motor. So I am quickly going through that motor part because you know the permanent and synchronous motors are better in performance compared to induction motors. And BLDC motor, that is being widely used in low power EVs because for high power the cost of the BLDC motor is not affordable. So for low power EVs like bikes or auto rickshaw, even the BLDC motor is now preferred because of its high power density compared to smaller weight. And of course, the power converters, the development is actually goes to the credit goes to the development of power semiconductor devices. Yes, earlier it started with SCR, thyristor family. SCR was a major device being used. Then gradually MOSFET, IGBT came, and IGBT became more popular. Even MOSFET because of the many advantages of IGBT over MOSFET. But nowadays we know the wide bandgap devices, silicon carbide and gallium nitride devices are gradually replacing these IGBTs and MOSFET. Coming to power converters, we know there are 4 different categories of power converters. They are AC to DC converters, DC to DC converters, DC to AC converters, and AC to AC converters. So what type of power converters is being used in electric vehicles? So we have 2 types of converters. One converter is required at the motor end, right? So if the motor is a DC motor, So then you will have a DC to DC converter is there. If the AC motor is an AC motor, the output of the battery will be DC. So we need an inverter for DC to AC inverter required. And for charger part we need AC to DC converters because the input will be AC. So for on-board chargers, the input will be AC, and for off-board chargers, input will be directly DC. So there also we need a DC to DC converter. So wherever there is an AC to DC converter also, so the AC to DC converter will be the front end, and there will be a back end DC to DC converter for stabilizing the voltage. So type of DC converters, DC to DC converters, we know it is known as choppers, DC to AC converters, inverters. And so we know the difference between hard switching and fast switching, source switching. So in order to achieve source switching, I hope many of you have studied power electronics. In order to achieve source switching, we go for zero voltage switching or zero current switching. So source switching DC to DC converters are also available in the market. Then of course we have in the DC to DC converters, isolated converters and non-isolated converters are available. So what are the basic types of non-isolated converters? You have studied, right? Buck converter, boost converter, buck boost converter, etc. And for isolated converters, we have derived topologies. What are the examples? Push-pull converter, forward converter, flyback converter, etc. So the converters are selected according to the various criteria like power level, voltage level, current level, frequency level, etc. Then we need, I mentioned when the motor is an AC motor and the battery output will be DC. So we need a DC to AC converter, which is an inverter. So there are different types of inverters. Starting we know the fundamental inverter is a two-level inverter, which produces one positive level and one other negative. And we have a lot of advances in inverters like multi-level inverter. So we have in multi-level inverter various categories like diode clamped multi-level inverter, capacitor clamped, cascade edge bridge inverter, active neutral point clamp, T-type multi-level inverter, which is nowadays very popular for electric vehicles, then modular multi-level converter, PUC converters, etc. And the battery chargers, I mentioned there are two types of battery chargers. What is the difference between on-board charger and off-board charger? On-board charger, the charger will be residing inside the vehicle, right? And off-board charger, the charger will be at the charging station. And there are three levels, so basically three levels of chargers, level 1, level 2 and level 3 chargers. And level 1 and level 2 belongs to AC chargers, on-board chargers, and the level 3 charger is DC fast charger. So the DC charger will be a fast charger. So off-board and on-board chargers and the DC charger, you may get 80% charge in say 10 to 15 minutes. And on-board charger, you can see a charger will be there inside the vehicle. So at your charger side or charging station, it will be AC supply. And that AC is directly given into your charger which is residing in your electric vehicle. So there will be an AC to DC converter, right? So first there will be an AC to DC converter as the charger part. Front end, we can say front end. So at the front end there will be an AC to DC converter. Then there will be another converter at the back end before giving to the battery. And that will be a DC to DC converter. So the DC to DC converter will basically stabilize the voltage, okay. And the output of the DC to DC converter will be fed to the battery. So there will be it will be a two-step process, okay. Two-step process. First there will be an AC to DC converter which will act as a fast front end, and there will be a DC to DC converter which will act as a back end. So on-board chargers are level 1 and level 2 chargers both belong to on-board. The difference is in the voltage level. In the level 1, basically the voltage will be 110 volt, and level 2 it will be around 230 volt. That depends on again on country and road. And of course level 2 charger will be faster than level 1 charger because the charging ampere will be more in level 2 charger. So now I will discuss a few topologies, not all the topologies because there are a number of topologies being published in the literature on the chargers, but I will be presenting a few fundamental topologies. So this you can see a unidirectional converter because nowadays there is a trend for converting the power of electric vehicle back to grid. That is known as vehicle to grid. The conventional power flow is from grid to vehicle, right? So nowadays bidirectional operations or bidirectional chargers are coming where the power available in the vehicle can be fed back to the grid. So this is a unidirectional converter, one directional converter. So you can say fundamental AC to DC converter or our simple rectifier is enough for doing this unidirectional process. And bidirectional, as mentioned, what you need to put, make it the converter bidirectional. Okay. So you can, the advantage is that you can have bidirectional flow from vehicle back to grid. So this is basically known as V2G operation. V2G operation is possible with bidirectional. That means if you are charging your vehicle in the daytime, okay, and we know the power shortage comes in the night time. So you can feed back the power available because all the electric vehicles will be a power source, a battery, fully charged. But so you can meet the shortage in power during the peak time by powering back the power available in the vehicle to grid. So you need a two-directional or bidirectional topology for that. Then interleaved, another kind of topology is interleaved topology. So this interleaving is basically used for reducing the plant load. So it will be a parallel connected inductance, so you can see the interleaved topology. So it will be a parallel connected inductance, so current will be divided and ultimately you will get an input, reduced input current ripple using interleaved topology. Then as I mentioned, instead of a two-level motor, you can go for multi-level operation. By adding more number of switches, so you can see this will increase the number of levels. So multi-level inverter topologies can also be used. So that the advantage is that the requirement of passive filters could be reduced using multi-level. Because using multi-level, you can more approximate a step in the waveform. You will get a more number of steps in the waveform. So it will approximate a sine wave. So the harmonic distortion will be less. So you need only very small passive filters to filter out the harmonic components. Then another, these are front-end topologies where the AC to DC, the converter will be an AC to DC converter. And as I mentioned, it is a two-step process. So there will be a DC to DC converter at the back end. So now we will discuss a couple of DC to DC converter topologies. So one is basically we know a buck converter. We know a buck converter converts a voltage from a DC voltage from a higher voltage to lower voltage. So you can have a buck converter at the secondary side or the step 2 also. So the buck converter will give the actual voltage required to the battery for charging it. Then we can have, instead of a buck converter, you can have a half-bridge DC to DC converter. So you have studied half-bridge topologies. So you can have a half-bridge DC converter instead of a buck converter. Then we can have, as I mentioned, topologies with galvanic isolation using a high-frequency transformer. So I hope you have studied these kind of topologies. So you can have isolation also, galvanic isolation. You need a high-frequency transformer there for this operation. Then another topology is a dual active bridge. This is a slightly complicated one. So you can have two bridges where you can have control from both the bridges. Okay. So by suitably controlling the firing angle, so you can have a power transfer from both the directions, either from input side to output side or from output side to input side. So this is known as, popularly known as DAB, dual active bridge. So where we will have two active bridges. And as I mentioned, resonant converters, again, the advantage with switching compared to fast switching. So you can have still a higher efficiency. So when there is a hard switching, there are some power loss associated with it. You can completely avoid the loss while the switching on and the switching off process by completely making it source switching. Okay. So there are basically two types of topology, zero voltage switching and zero current switching. So by employing the zero voltage switching or zero current switching, you can have an improved efficiency. Even an efficiency above 99% is possible. Then you will have to add that source switching part also to the converter and make it a resonant converter. Okay. And another type of charger is integrated battery charger. Okay. So you can have, so you have a machine is there, right? A motor. So you can use the windings of the motor for filtering purpose. Okay. So that is known as integrated battery chargers. So you can use the, so we will use the battery, the charger plus the motor. Okay. So that will act as a filter in it. So that is known as, in the lot of work is happening this integrated battery charger also. So for researchers and all, this is a very good topic. Lot of papers are being published in this topic, integrated battery chargers. Then coming to off-board charger, I mentioned it is a level 3 charger, it's a DC fast charger. Okay. So where the charger will be outside the vehicle. Okay. So it will be DC, high voltage DC, high power DC. Okay. Again, lot of topologies are there. So where also there will be an AC to DC converter which will be at the station, because the power available, readily available power is AC. So there will be an AC to DC converter in the charging station, and there will be a DC to DC converter also, say, in the charging station itself. So both the converters, AC to DC and the DC to DC converters, will be there at the charging station, not in the vehicle. So again, lot of topologies are there. As I mentioned, there are two types of converters: a front-end converter, which will be an AC to DC converter. Then at the back end, there will be a DC to DC converter. So AC to DC converter, bidirectional operation, unidirectional operation, both the converters are available. So if you want to make it bidirectional, you have to control the switches accordingly. Then again, interleaved topologies for reducing the ripples. Then multi-level topologies for reducing the filtering size, passive filters, right? So when you go for distortion, is getting reduced, so you need only lesser size of passive filters. Then at the back end, so front end there will be an AC to DC converter, at the back end there will be a DC to DC converter. Again, you can go for many type of topologies. So first one will be a unidirectional topology, which can be an interleaved topology also. Okay. So it can be a buck converter, boost converter also, depending on the voltage level of the battery. Okay. If the battery level voltage is higher than the input voltage, then you can go for a boost converter. Otherwise, you can go for a buck converter, or even according to the voltage, you can have a buck boost converter also. Then three-phase topologies, because all the chargers will be three-phase chargers only for level 3 chargers, because the rating is high, the power rating is high. So all the chargers will be three-phase chargers only. So with the galvanic isolation. And in addition to the charger, there are in electric vehicles, there are many other auxiliary circuits where also a lot of power electronic converters are used. But for auxiliary circuits, we know the voltage level will be, the voltage level and the current level will be very small. So the power converters are used, but the power converters will be having very low power level. Normally flyback converter or forward converter, that kind of converters are used. Where what will be the other auxiliary power supplies required? Say starter motor, say or power window, or power steering. There are all small motors small motors are there, and other electronic media, player, etc. Where there will be a requirement of 12 volt, 24 volt, or 6 volt, or even 3 volt. With a small power handling capacity, 10 watts, 20 watts, 50 watts, etc. So there all we will go for very small power electronic converters. Okay, isolated. Most of the converters will be isolated DC to DC converters. Okay, like flyback converter. Flyback converters are very commonly used in many of these applications. And we can have a unified topology for EV battery and auxiliary battery, because we have main big EV battery and we have a very small auxiliary batteries are also there. So you can have a combined topology. You see the topology. So from the same grid you will have an AC to DC converter, one for battery. Okay, main battery, AC to DC, then DC to DC, which will be going to the battery. And you can have an isolation transformer, a step down transformer. Okay. And you can have again a reduced DC, which will be given for small batteries, okay. So which will be given for auxiliary batteries. So you can have a single circuit which gives you both the options, okay. A voltage which is suitable for the main battery, and an voltage which is suitable for the auxiliary battery. And charging techniques I mentioned in the beginning, there are wireless charging technologies also. Now wireless charging technologies are very commonly used. We know basically there are two types of topologies, inductive topologies and capacitive power topologies, and a combination of that inductive and capacitive topologies are also available. And in the charging part, the main charging topology is CC-CV topology. See, there is CC charging, constant current charging, then CV charging, constant voltage charging, then CC-CV charging is there, constant current, constant voltage charging is also there. Then wireless topologies are known as WPT, wireless power transfer topologies. There are two major categories, inductive power transfer and capacitive power transfer. So this is one inductive power transfer topology where a full bridge is used with an LC filter. Okay. So this will help to transfer the power wirelessly from the transmitter side to receiver side. Then another topology is half-bridge topology, which is also used along with an LC circuit. The LC circuit basically helps in getting the wireless charging. Then again you can go for multi-level option also, as I mentioned earlier. Then so far we discussed the various types of chargers. On-board charger, off-board charger, they are conductive chargers and wireless chargers also. Then the type of power converters used for machines, for DC machines as well as AC machines. So for DC machines we need only DC to DC converter, right? Because output of the battery is DC and input of the DC motor is also DC. So you need only DC to DC converter. So we need only DC to DC converters for DC machines. So you can see like this, only DC to DC converter. Then for AC motors, of course, the output of the battery is DC and input of the AC motor is AC. So we need a DC to AC converters. So basically we can go for a three-level inverter, three-level inverter, three-phase, two-level inverter or three-level inverter. We can add a zero also, or even multi-level inverters also. And you can go for a current source inverter also. In addition to voltage source inverter, you can go for a current source inverter. So we know there are some advantages with the current source inverter or voltage source inverters. And the multi-level topology, again a beautiful topology. So where you can reduce the passive filter requirement. There are a lot of types of multi-level inverters used, and the fundamental three topologies are diode, clamped, capacitor clamped, and cascade edge bridge inverters. There are and the T-type multi-level inverter, which is an advanced topology, which is very now commonly used in electric vehicles because of its higher efficiency. And you can have a unified, as we mentioned about the unified system for battery charger and auxiliary battery charger. Like that we can have a unified system for our battery charger and the traction motor. Okay. So we will discuss a few topologies. So you can see this topology. So there is a motor there, a grid is there. So it is directly going to the EV battery, and so if the motor is an induction motor, three-phase AC motor, so you can directly give the power supply to the AC motor. And you see from the AC power supply it is converted into DC and going to battery. So this is a unified converter. So where the two converters are integrated in the single converter. So from the grid you will be giving to the motor as well as to the battery. Then another option is open-end winding machine. So you can keep the terminals open and you can connect like this. See. So you can put the machine in between the converter part, so and the grid. So this is known as, so we will be opening the terminals. So we know for an induction motor the secondary will be closed, either through slip rings or short-circuited bars. So instead of that you keep it open. Take all the 6 terminals. Okay. So then you will get this open-end winding machine, and again lot of work is happening in this open-end winding machine motors. Then another part is a battery management system, BMS. So we need cell level management, module level management, and the total battery level management. So depending on whether it is cell level, module level, or the whole battery pack, the voltage level is different, right? So for the cell level, the voltage may be 1 volt or 2 volt. So under the module level, it may be say 20 volt, 12 volt or 24 volt. And for battery pack level, it may be a 350 volt, 600 volt or 800 volt, like that. So different types of DC to DC converter. All the DC power converters will be DC to DC converters here. And different voltage level, different power level DC to DC converters will be used. And for the small voltage level, flyback converters are commonly used, and for high power level it may go to buck converter or SPEC converter or CHUK converter, and many other topologies are also available. And regarding emerging technologies, where also the power electronics technology is coming is, one is I mentioned about vehicle-to-vehicle communication. Now we have discussed from grid to vehicle, right? Grid to vehicle, then vehicle to grid using bidirectional charges. And nowadays there is a charging from one vehicle to another vehicle. So you take the charge of one vehicle, battery, and you can use that battery for charging another vehicle. That is vehicle to vehicle charging is there. Now the papers, research papers are available from vehicle to vehicle charge. The papers are available. So you can, suitable converters are defined for this, and it is implemented, vehicle to vehicle charging. And then actually this connection is basically vehicle to X. There are a lot of communication technologies are there. So we can say vehicle is V2X, there are a lot of vehicle to pedestrian, vehicle to vehicle, vehicle to infrastructure, lot of vehicle to grid. So all these together known as V2X. Basically a vehicle is a computer on the grid, like that now it is coming. Because all it will be, the complete operation is the computer controlled one. No, I am talking about an autonomous electric vehicle, not a manual electric vehicle. When the electric vehicle becomes autonomous, it is actually V2X. It is a computer in the grid, we can say. And nowadays lot of AI techniques are also coming, especially for autonomous vehicles, definitely lot of AI techniques will come. And the charging also, so optimal charging, where to place the chargers, and how, what about the range of the battery, where should be the charger locations, and all are being developed, and a lot of research papers are, and a lot of papers are available with machine learning algorithms for finding the suitable location of the charging stations, etc. So a lot of research is happening on many aspects, not only the power converters. Power converters is a core area, and nowadays a lot of other motors are also coming, SRM motors, switched reluctance motor, synchronous reluctance motor. Accordingly, the various power converters are being developed. And the chargers, on-board charger, off-board charger, wireless charger, and another important point I mentioned is the location of the chargers. So for all that, a lot of algorithms using machine learning algorithm, people are working with the machine learning algorithm to suitably place the charging locations and to predict the life of the battery, the range of the battery. So a lot of machine learning algorithms are used to predict the charge, and you can accordingly, you can plan your travel, and you can plan the charging of your battery. So with this I am stopping, and I am open to questions if you have any.
Participants can clear doubts. Any queries?
Yes.
Yeah, thank you for the very nice speech. I have a question about the topology. You see, you have in India, let's say, also investigations and some efforts to build up your own cars. Which topology for charging you see here?
Charging?
For charging the electric vehicles, you see also bidirectional charging, or you just see it now in the, let's say, next years, just easy one?
Now in India and all, our unidirectional charger is very common. We know we charge from using either level 1 or level 2 or level 3 charging. Most of the people try with, say if their travel is a city travel only, so they need a charging from home only. So they will go for their AC charging. And when people are traveling a lot, of course the AC charging is not enough. So there people will be going for DC charging, power available at the charging station. And all these are unidirectional chargers. Nowadays Government of India is recommending and developing standards for bidirectional chargers, because we know our country is still in a power crisis during peak time. Because people are taking charge, the power from grid for charge. Now the grid demand is also heavily increased with the introduction of these electric vehicles. And especially if people charge during night also, then again the power demand during peak time is again increasing. So how to meet this power demand? Because we have an electric vehicle as a battery source or as a power source. So we can feed that power available in the electric vehicles back to grid. So for that we need a bidirectional chargers. And in the government is, because we need a correct, exact standards for these chargers. So once the chargers are being developed, standards are being developed and it is tested, then only we can make it completely commercial. And very soon it is going to be very common in India. People have just started using it, but the Government of India, the policy makers and regulatory commission and the Government of India, EV policy, etc. also have to give necessary recommendations, and it is in the stage, actually that stage, and very soon all these standards will be developed for these bidirectional chargers, and these bidirectional chargers is going to be very common in India very soon.
So it needs some time. So
but it will happen very soon.
Okay, because in Europe we have the same situation. So the bidirectional charging is in the mind since more than 10 years. But so now, even now, it's not common. You have some cars, they can support vehicle to load, but vehicle to grid is still uncommon. I think it's estimated in 2025 to 2026, it will become a standard.
So another 3 years. Hopefully.
Hopefully. But in India, I think with your, let's say, very weak grid at some times, then
Yeah, lot of things, aspects to be considered. Yeah.
then it's more important to have.
Because grid capacity, grid penetration, so there are some regulations on the back feeding. So even renewable energy, so solar also we connect back to grid, there are some regulations. So we have to check with all the regulatory compliances.
Another question about charging. Do you also think about wireless charging?
Yeah, well, now wireless charging, even Tesla has developed wireless chargers. And earlier the problem was with the amount of power that could be transferred using wireless charging. It was less. But nowadays that the power capacity is also increased with the wireless charging. With a lot of, as I mentioned, inductive power transferology capacity. And nowadays there is in research papers we can see a combination of both, inductive plus capacity. That gives a better power transfer capability. So very in near future this wireless charging we will definitely see very common.
Okay, thank you.
Any other questions?
Please come forward, please.
I wanted to know how would you recycle or repurpose the materials being used for batteries, and I have also been thinking that when discussing about EV vehicles in my house, my parents were really concerned about the damages and explosions. They always look at it like some dangerous thing, and it is still new to them maybe, but how do you propose that you reach into wider audiences?
Yeah, got the point. The safety, because recently you have seen some fire. So basically, the reason is the poor quality of the hardware. That is the only reason. Okay. So if you have proper quality of the charger and associated electronic components, it shouldn't get fired. Okay. It should work correctly. So these things happen. The major reason is the poor quality of the electronic hardware components. And another reason can be the heating. Actually, that also being controlled, again the heating, overheating also being caused due to the lack of the proper design. But that is very rare case only, because we have enough regulatory compliances and all, so that won't be going to be a worry. It's a case-to-case, occasional cases only, and hope that kind of things won't repeat. And actually the technology is foolproof. Okay, so now we have very good hardware to control everything. BMS basically, as I mentioned, the battery heating is a problem. So we have a concrete BMS technology, battery management technology, where all these control hardware circuit and control circuit is all well developed. So only in few cases where the quality of the hardware is not that much great, where these things can happen. But these things are occasional cases only, and I am sure that won't be a problem in future. And another concern regarding battery. So battery, that has to be, we know that has to be recycled, because we have to replace a battery in every, say, 5 years or 6 years. So the recycling of batteries is another issue. That has to be anyway taken care, because there should be some good technology. Actually, there are technologies, and that also will be definitely taken care for the battery case also, recycling case also. Okay.
Any more queries?
Good afternoon, Professor.
Good day.
I'm just coming in and heard you are talking about this e-vehicle and the batteries and lack of it. I I have a paper which I'm currently doing on the safety of the batteries. But before that, in my school, they brought a e-car that is being made by GMC India, right? Then they said to me, this car is no good. I said, why? This car only runs for a few hours and we have to take 12 hours to charge the battery. Then I said to myself, wow, so is it the way this e-car people are making it? So my question here is, I'm talking about the efficiency and also the recyclability of these batteries. Because like, I'm African, right? We don't have technology to recycle a battery. And also environmental, I'm very conscious because my master was environmental engineering. So for me, I'm very conscious about the batteries, understand? Because when they get to the water system, understand, bioaccumulations, bioconcentrations, you know, it's going to create a lot of problem on carcinogenicity. And now we know around the world, at the very recent, was it 2 weeks ago, I had one Indian lady, you know, was diagnosed with cancer and she died cancer-related issue. So batteries get into water system or food system, you know, bioavailability, bioconcentration, actually is getting big problem around the world. So how effectively this technology we are talking about, how it's going to take care of this safety aspect, not only the heating my gentleman was talking about, but also after the safe life of this battery, how are you going to regenerate it back to come to the system so that we can use it? We cannot just dump it anywhere so that it can affect the environment and the ecosystem. Thank you.
Okay, so your question is basically on hello? So your question is basically on recycling. Okay. So as I mentioned, one is so we can have the bidirectional operation while the battery is free. Okay, we can have a bidirectional charger and feedback to the grid. So that because anyway the battery life will be say for maximum 5 years or 6 years. So instead of putting it in idle, so you can have this bidirectional operation so that you can have the maximum utility of the battery. Okay. Then the second case is about the battery replacement and the battery fire. As I was answering to the previous question, so if you properly design the hardware components, then the heating of the battery won't be a bigger problem. Then regarding battery recycling, that is a next challenge. So how to recycle battery and again, because otherwise it will be a big e-waste, right? So okay. So anyway, a lot of chemical processes are there, and I'm not an expert in that chemical process, how this recycling and all. But I'm sure that is being taken care of because a lot of again some research work is happening in that area because that has to happen. Otherwise, there will be a big dumping of this e-waste with the battery. Anyway, we will have to safely handle that, and a lot of technologies will be developed to properly recycle the battery and again come with good solutions. And otherwise, another problem with this, if you are not able to suitably recycle the battery, then the pollution issue, right? And that also to be considered because so when we are talking about this EV and all, we say pollution free, greener. But if we are not able to manage the battery properly, these things won't work. So anyway, I'm sure the research work is happening in the area of these battery technologies. I am not an expert in this chemical engineering to give the finer aspects about that, but I'm sure the technology is being developed and this issue will be taken care surely in the future. Thank you.
Any more left?
Sir, can you just tell me the reliability of the EV cars?
Yeah, sure. So the reliability again, that I'm talking about the reliability. The machine, there are different parts in EV. The major part is a motor, right? A AC motor or DC motor. That is reliable. And in the BLDC motor, you can say any concern for reliability in the motor side is with the driver of the BLDC motor. So there will be a driver or electronic voltage controller for a BLDC motor. So there is an electronic circuit. But that also, if you design it properly, then the reliability won't be an issue. Then power converters, we know nowadays very good cooling system, very good all controls and there all the closed loop circuits. So all the powertronic circuits should for 10 years or 15 years. The only concern is regarding the BMS. So there the small issue can come in the BMS only, battery management systems. So unless you design the BMS circuit properly, there can be a small heating and all. Some still hope any kind of reliability issue may come only in the battery management system part, BMS. And I think otherwise, except this BMS, this should be mostly reliable EV. So generally we can very say that this EV is a reliable system. Okay.
Any more queries? Okay. Thank you, sir, for that enlightening session and for clearing all our doubts. Now I invite session chair, Professor Dr. Ulf Swal, Head of the Institute for Renewable Energies and Electromobility, to deliver the vote of thanks.
So, I thank you, Mr. Biju, for this very interesting and wide speech, and I think we get a good impression about the status of the electric vehicle investigation and also from the status of the setup in India and all over the world. I think it should be a good possibility also for your students to know about the standards and to improve this technology to reach more green environment. So after this, I also have a speech and also want to give you some details for battery recycling, because I was very interested in your question, and we have the same problems in Germany also already. So we build up there some reusable or some second life energy storage systems. And also we have partners for recycling battery materials, because we have the problems right now that the material is let's say very rare, and we have to recycle it very close to 100%. So I also want to give you later on some hints for this. So thank you, Mr. Biju, and I think we should proceed then.
Sir, please. As a token of our love and gratitude, we would like to present the certificate to Dr. Biju K. Process card, please do the honor. Thank you, Professor. We shall break for lunch now. Lunch is arranged at the room. The next session of keynote lecture by Dr. Ulf Swal and Mr. Nishant Unikrishnan will commence at 1:40 p.m. So all please join. Thank you all.
Ours is a world that is constantly It's this sense of wonder that drives us each and every day. For more than 25 years, we have constantly improved upon a rich tradition. Today, Arjuna is India's leading manufacturer of of botanical extracts for the pharmaceutical and nutraceutical industries. Yet each day begins with the desire to challenge the day before, with the passion for seeking better solutions. A whole community now follows the best practices in farming, having gained exposure from the programs initiated by Arjuna. Today, our farmers have been familiarized with the ever-growing applications of technology in agriculture. For them, farming has become a dynamic industry, one that supports better lifestyles for them and their families. Where does all this begin? Where does the sense of wonder spark? The research and development wing of Arjuna, consisting of more than 40 scientists, is the torchbearer for our continual march forward. For years, our team has channeled their sense of wonder into developing a string of evidence-based solutions that have touched millions of lives around the world. Be it BCM95 or Oxystorm, the ideology behind every product is rooted in India's rich culture of Ayurveda. This has helped us remain 100% natural with our products, even while enhancing them. Our frontline production technology retains the natural goodness of the raw materials. And by maintaining an impeccable order of hygiene and responsible practices, we ensure that there is only but a minimal impact to the environment around us. At Arjuna, we are constantly on our toes to find inspiration from both the global market and from our customers.
With customers from more than 50 countries and a product range that extends from the extracts of turmeric, red spinach, boswellia, pomegranate, amla, ashwagandha, and over 40 herbal and plant extracts and essential oils.
We are constantly striving to be at the forefront of innovation. This first-hand knowledge and experience has been vital to us for meeting the market requirement and for staying ahead of the game. We look out into the future in the same way we look into the past, because we believe they are mutually inspiring. Our name, Arjuna, is in fact borrowed from Indian mythology, a glorious hero, renowned for his unmatched skills and wholesome devotion to his purpose. The timeless practice of Ayurveda is our rich legacy of knowledge for a better tomorrow. We are both excited and equipped to foray deeper into the world of health and nutrition, fueled by our sense of wonder. This methodical approach of stirring innovation in the world sets the basis for our motto, Science of Nature. Ours is a world that is constantly evolving. Each day comes with change, sometimes drastic, sometimes subtle. Amongst numerous factors, one that significantly drives the world forward is a sense of wonder, a puzzlement, one that excites, one that opens new avenues and possibilities. This sense of wonder is revolutionizing industries and the lives of people around the world. Consumers now enjoy a wide variety of choices, and brands have to constantly strive to gain an edge in the process. Our way of doing just that has to do with indulging in that sense of wonder. Not simply to remain in the game, but to lead it. It's this sense of wonder that drives Arjuna each and every day. For more than 25 years, we have constantly improved upon a rich tradition. Today, Arjuna is India's leading manufacturer of botanical extracts for the pharmaceutical and nutraceutical industries. Yet each day begins with the desire to challenge the day before, with the passion for seeking better solutions. A whole community now follows the best practices in farming, having gained exposure from the programs initiated by Arjuna. Today, our farmers have been familiarized with the ever-growing applications of technology in agriculture. For them, farming has become a dynamic industry, one that supports better lifestyles for them and their families. Where does all this begin? Where does the sense of wonder spark? The research and development wing of Arjuna, consisting of more than 40 scientists, is the torchbearer for our continual march forward. For years, our team has channeled their sense of wonder into developing a string of evidence-based solutions that have touched millions of lives around the world. Be it BCM 95 or Oxystorm, the ideology behind every product is rooted in India's rich culture of Ayurveda. This has helped us remain 100% natural with our products, even while enhancing them. Our frontline production technology retains the natural goodness of the raw materials, and by maintaining an impeccable order of hygiene and responsible practices, we ensure that there is only but a minimal impact to the environment around us. At Arjuna, we are constantly on our toes to find inspiration from both the global market and from our customers.
With customers from more than 50 countries and a product range that extends from the extracts of turmeric, red spinach, boswellia, pomegranate, amla, ashwagandha, and over 40 herbal and plant extracts and essential oils,
we are constantly striving to be at the forefront of innovation. This first-hand knowledge and experience has been vital to us for meeting the market requirement and for staying ahead of the game. We look out into the future in the same way we look into the past, because we believe they are mutually inspiring. Our name, Arjuna, is in fact borrowed from Indian mythology, a glorious hero, renowned for his unmatched skills and wholesome devotion to his purpose. The timeless practice of Ayurveda is our rich legacy of knowledge for a better tomorrow. We are both excited and equipped to foray deeper into the world of health and nutrition, fueled by our sense of wonder. This methodical approach of stirring innovation in the world sets the basis for our motto, Science of Nature. Ours is a world that is constantly evolving. Each day comes with change, sometimes drastic, sometimes subtle. Amongst numerous factors, one that significantly drives the world forward is a sense of wonder, a puzzlement, one that excites, one that opens new avenues and possibilities. This sense of wonder is revolutionizing industries and the lives of people around the world. Consumers now enjoy a wide variety of choices, and brands have to constantly strive to gain an edge in the process. Our way of doing just that has to do with indulging in that sense of wonder, not simply to remain in the game, but to lead it. It's this sense of wonder that drives Arjuna each and every day. For more than 25 years, we have constantly improved upon a rich tradition. Today, Arjuna is India's leading manufacturer of botanical extracts for the pharmaceutical and nutraceutical industries. Yet each day begins with the desire to challenge the day before, with the passion for seeking better solutions. A whole community now follows the best practices in farming, having gained exposure from the programs initiated by Arjuna. Today, our farmers have been familiarized with the ever-growing applications of technology in agriculture. For them, farming has become a dynamic industry, one that supports better lifestyles for them and their families. Where does all this begin? Where does the sense of wonder spark? The research and development wing of Arjuna, consisting of more than 40 scientists, is the torchbearer for our continual march forward. For years, our team has channeled their sense of wonder into developing a string of evidence-based solutions that have touched millions of lives around the world. Be it BCM 95 or Oxystorm, the ideology behind every product is rooted in India's rich culture of Ayurveda. This has helped us remain 100% natural with our products, even while enhancing them. Our frontline production technology retains the natural goodness of the raw materials, and by maintaining an impeccable order of hygiene and responsible practices, we ensure that there is only but a minimal impact to the environment around us. At Arjuna, we are constantly on our toes to find inspiration from both the global market and from our customers.
With customers from more than 50 countries and a product range that extends from the extracts of turmeric, red spinach, boswellia, pomegranate, amla, ashwagandha, and over 40 herbal and plant extracts and essential oils,
we are constantly striving to be at the forefront of innovation. This first-hand knowledge and experience has been vital to us for meeting the market requirement and for staying ahead of the game. We look out into the future in the same way we look into the past, because we believe they are mutually inspiring. Our name, Arjuna, is in fact borrowed from Indian mythology. A glorious hero, renowned for his unmatched skills and wholesome devotion to his purpose. The timeless practice of Ayurveda is our rich legacy of knowledge for a better tomorrow. We are both excited and equipped to foray deeper into the world of health and nutrition, fueled by our sense of wonder. This methodical approach of stirring innovation in the world sets the basis for our motto, Science of Nature. Ours is a world that is constantly evolving. Each day comes with change, sometimes drastic, sometimes subtle. Amongst numerous factors, one that significantly drives the world forward is a sense of wonder, a puzzlement, one that excites, one that opens new avenues and possibilities. This sense of wonder is revolutionizing industries and the lives of people around the world. Consumers now enjoy a wide variety of choices, and brands have to constantly strive to gain an edge in the process. Our way of doing just that has to do with indulging in that sense of wonder. Not simply to remain in the game, but to lead it. It's this sense of wonder that drives Arjuna each and every day. For more than 25 years, we have constantly improved upon a rich tradition. Today, Arjuna is India's leading manufacturer of botanical extracts for the pharmaceutical and nutraceutical industries. Yet each day begins with the desire to challenge the day before, with the passion for seeking better solutions. A whole community now follows the best practices in farming, having gained exposure from the programs initiated by Arjuna. Today, our farmers have been familiarized with the ever-growing applications of technology in agriculture. For them, farming has become a dynamic industry, one that supports better lifestyles for them and their families. Where does all this begin? Where does the sense of wonder spark? The research and development wing of Arjuna, consisting of more than 40 scientists, is the torchbearer for our continual march forward. For years, our team has channeled their sense of wonder into developing a string of evidence-based solutions that have touched millions of lives around the world. Be it BCM95 or Oxystorm, the ideology behind every product is rooted in India's rich culture of Ayurveda. This has helped us remain 100% natural with our products, even while enhancing them. Our frontline production technology retains the natural goodness of the raw materials, and by maintaining an impeccable order of hygiene and responsible practices, we ensure that there is only but a minimal impact to the environment around us. At Arjuna, we are constantly on our toes to find inspiration from both the global market and from our customers.
With customers from more than 50 countries and a product range that extends from the extracts of turmeric, red spinach, boswellia, pomegranate, amla, ashwagandha, and over 40 herbal and plant extracts and essential oils.
We are constantly striving to be at the forefront of innovation. This first-hand knowledge and experience has been vital to us for meeting the market requirement and for staying ahead of the game. We look out into the future in the same way we look into the past, because we believe they are mutually inspiring. Our name, Arjuna, is in fact borrowed from Indian mythology, a glorious hero, renowned for his unmatched skills and wholesome devotion to his purpose. The timeless practice of Ayurveda is our rich legacy of knowledge for a better tomorrow. We are both excited and equipped to foray deeper into the world of health and nutrition, fueled by our sense of wonder. This methodical approach of stirring innovation in the world sets the basis for our motto, Science of Nature. Ours is a world that is constantly evolving. Each day comes with change, sometimes drastic, sometimes subtle. Amongst numerous factors, one that significantly drives the world forward is a sense of wonder, a puzzlement, one that excites, one that opens new avenues and possibilities. This sense of wonder is revolutionizing industries and the lives of people around the world. Consumers now enjoy a wide variety of choices, and brands have to constantly strive to gain an edge in the process. Our way of doing just that has to do with indulging in that sense of wonder, not simply to remain in the game, but to lead it. It's this sense of wonder that drives Arjuna each and every day. For more than 25 years, we have constantly improved upon a rich tradition. Today, Arjuna is India's leading manufacturer of botanical extracts for the pharmaceutical and nutraceutical industries. Yet each day begins with the desire to challenge the day before, with the passion for seeking better solutions. A whole community now follows the best practices in farming, having gained exposure from the programs initiated by Arjuna. Today, our farmers have been familiarized with the ever-growing applications of technology in agriculture. For them, farming has become a dynamic industry, one that supports better lifestyles for them and their families. Where does all this begin? Where does the sense of wonder spark? The research and development wing of Arjuna, consisting of more than 40 scientists, is the torchbearer for our continual march forward. For years, our team has channeled their sense of wonder into developing a string of evidence-based solutions that have touched millions of lives around the world. Be it BCM 95 or Oxystorm, the ideology behind every product is rooted in India's rich culture of Ayurveda. This has helped us remain 100% natural with our products, even while enhancing them. Our frontline production technology retains the natural goodness of the raw materials. And by maintaining an impeccable order of hygiene and responsible practices, we ensure that there is only but a minimal impact to the environment around us. At Arjuna, we are constantly on our toes to find inspiration from both the global market and from our customers.
With customers from more than 50 countries and a product range that extends from the extracts of turmeric, red spinach, boswellia, pomegranate, amla, ashwagandha, and over 40 herbal and plant extracts and essential oils.
We are constantly striving to be at the forefront of innovation. This first-hand knowledge and experience has been vital to us for meeting the market requirement and for staying ahead of the game. We look out into the future in the same way we look into the past, because we believe they are mutually inspiring. Our name, Arjuna, is in fact borrowed from Indian mythology, a glorious hero, renowned for his unmatched skills and wholesome devotion to his purpose. The timeless practice of Ayurveda is our rich legacy of knowledge for a better tomorrow. We are both excited and equipped to foray deeper into the world of health and nutrition, fueled by our sense of wonder. This methodical approach of stirring innovation in the world sets the basis for our motto, Science of Nature. Ours is a world that is constantly evolving. Each day comes with change, sometimes drastic, sometimes subtle. Amongst numerous factors, one that significantly drives the world forward is a sense of wonder, a puzzlement, one that excites, one that opens new avenues and possibilities. This sense of wonder is revolutionizing industries and the lives of people around the world. Consumers now enjoy a wide variety of choices, and brands have to constantly strive to gain an edge in the process. Our way of doing just that has to do with indulging in that sense of wonder, not simply to remain in the game, but to lead it. It's this sense of wonder that drives Arjuna each and every day. For more than 25 years, we have constantly improved upon a rich tradition. Today, Arjuna is India's leading manufacturer of botanical extracts for the pharmaceutical and nutraceutical industries. Yet each day begins with the desire to challenge the day before, with the passion for seeking better solutions. A whole community now follows the best practices in farming, having gained exposure from the programs initiated by Arjuna. Today, our farmers have been familiarized with the ever-growing applications of technology in agriculture. For them, farming has become a dynamic industry, one that supports better lifestyles for them and their families. Where does all this begin? Where does the sense of wonder spark? The research and development wing of Arjuna, consisting of more than 40 scientists, is the torchbearer for our continual march forward. years, our team has channeled their sense of wonder into developing a string of evidence-based solutions that have touched millions of lives around the world. Be it BCM 95 or Oxystorm, the ideology behind every product is rooted in India's rich culture of Ayurveda. This has helped us remain 100% natural with our products, even while enhancing them. Our frontline production technology retains the natural goodness of the raw materials, and by maintaining an impeccable order of hygiene and responsible practices, we ensure that there is only but a minimal impact to the environment around us. At Arjuna, we are constantly on our toes to find inspiration from both the global market and from our customers.
With customers from more than 50 countries and a product range that extends from the extracts of turmeric, red spinach, boswellia, pomegranate, amla, ashwagandha, and over 40 herbal and plant extracts and essential oils,
we are constantly striving to be at the forefront of innovation. This first-hand knowledge and experience has been vital to us for meeting the market requirement and for staying ahead of the game. We look out into the future in the same way we look into the past, because we believe they are mutually inspiring. Our name, Arjuna, is in fact borrowed from Indian mythology, a glorious hero, renowned for his unmatched skills and wholesome devotion to his purpose. The timeless practice of Ayurveda is our rich legacy of knowledge for a better tomorrow. We are both excited and equipped to foray deeper into the world of health and nutrition, fueled by our sense of wonder. This methodical approach of stirring innovation in the world sets the basis for our motto, Science of Nature. Ours is a world that is constantly evolving. Each day comes with change, sometimes drastic, sometimes subtle. Amongst numerous factors, one that significantly drives the world forward is a sense of wonder, a puzzlement, one that excites, one that opens new avenues and possibilities. This sense of wonder is revolutionizing industries and the lives of people around the world. Consumers now enjoy a wide variety of choices, and brands have to constantly strive to gain an edge in the process. Our way of doing just that has to do with indulging in that sense of wonder, not simply to remain in the game, but to lead it. It's this sense of wonder that drives Arjuna each and every day. For more than 25 years, we have constantly improved upon a rich tradition. Today, Arjuna is India's leading manufacturer of botanical extracts for the pharmaceutical and nutraceutical industries. Yet each day begins with the desire to challenge the day before, with the passion for seeking better solutions. A whole community now follows the best practices in farming, having gained exposure from the programs initiated by Arjuna. Today, our farmers have been familiarized with the ever-growing applications of technology in agriculture. For them, farming has become a dynamic industry, one that supports better lifestyles for them and their families. Where does all this begin? us a world that is constantly evolving. Each day comes with change, sometimes drastic, sometimes subtle. Amongst numerous factors, one that significantly drives the world forward is a sense of wonder, a puzzlement, one that excites, one that opens new avenues and possibilities. This sense of wonder is revolutionizing industries and the lives of people around the world. Consumers now enjoy a wide variety of choices, and brands have to constantly strive to gain an edge in the process. Our way of doing just that has to do with indulging in that sense of wonder. Not simply to remain in the game, but to lead it. It's this sense of wonder that drives Arjuna each and every day. For more than 25 years, we have constantly improved upon a rich tradition. Today, Arjuna is India's leading manufacturer of botanical extracts for the pharmaceutical and nutraceutical industries. Yet each day begins with the desire to challenge the day before, with the passion for seeking better solutions. A whole community now follows the best practices in farming, having gained exposure from the programs initiated by Arjuna. Today, our farmers have been familiarized with the ever-growing applications of technology in agriculture. For them, farming has become a dynamic industry, one that supports better lifestyles for them and their families. Where does all this begin? Where does the sense of wonder spark? The research and development wing of Arjuna, consisting of more than 40 scientists, is the torchbearer for our continual march forward. For years, our team has channeled their sense of wonder into developing a string of evidence-based solutions that have touched millions of lives around the world. Be it BCM95 or Oxystorm, the ideology behind every product is rooted in India's rich culture of Ayurveda. This has helped us remain 100% natural with our products, even while enhancing them. Our frontline production technology retains the natural goodness of the raw materials. And by maintaining an impeccable order of hygiene and responsible practices, we ensure that there is only but a minimal impact to the environment around us. At Arjuna, we are constantly on our toes to find inspiration from both the global market and from our customers.
With customers from more than 50 countries and a product range that extends from the extracts of turmeric, red spinach, boswellia, pomegranate, amla, ashwagandha, and over 40 herbal and plant extracts and essential oils,
we are constantly striving to be at the forefront of innovation. This first-hand knowledge and experience has been vital to us for meeting the market requirement and for staying ahead of the game. We look out into the future in the same way we look into the past, because we believe they are mutually inspiring. Our name, Arjuna, is in fact borrowed from Indian mythology, a glorious hero, renowned for his unmatched skills and wholesome devotion to his purpose. The timeless practice of Ayurveda is our rich legacy of knowledge. Ours is a world that is constantly evolving. Each day comes with change, sometimes drastic, sometimes subtle. Amongst numerous factors, one that significantly drives the world forward is a sense of wonder, a puzzlement, one that excites, one that opens new avenues and possibilities. This sense of wonder is revolutionizing industries and the lives of people around the world. Consumers now enjoy a wide variety of choices, and brands have to constantly strive to gain an edge in the process. Our way of doing just that has to do with indulging in that sense of wonder, not simply to remain in the game, but to lead it. It's this sense of wonder that drives Arjuna each and every day. For more than 25 years, we have constantly improved upon a rich tradition. Today, Arjuna is India's leading manufacturer of botanical extracts for the pharmaceutical.
Delegates, please note, paper presentation session in room number IDC room will be held as per schedule. Please note, paper presentation session in room IEDC will be held as per schedule. It will commence at sharp 2:20 p.m. Please note, presentation session in room IEDC will be held as per schedule. It will commence at sharp 2:20 p.m.
Having gained exposure from the programs initiated by Arjuna. Today, our farmers have been familiarized with the ever-growing applications of technology in agriculture. For them, farming has become a dynamic industry, one that supports better lifestyles for them and their families. Where does all this begin? Where does the sense of wonder spark? The research and development wing of Arjuna, consisting of more than 40 scientists, is the torchbearer for our continual march forward. For years, our team has channeled their sense of wonder into developing a string of evidence-based solutions that have touched millions of lives around the world. Be it BCM95 or Oxystorm, the ideology behind every product is rooted in India's rich culture of Ayurveda. This has helped us remain 100% natural with our products, even while enhancing them. Frontline production technology retains the natural goodness of the raw materials, and by maintaining an impeccable order of hygiene and responsible practices, we ensure that there is only but a minimal impact to the environment around us. At Arjuna, we are constantly on our toes to find inspiration from both the global market and from our customers.
With customers from more than 50 countries and a product range that extends from the extracts of turmeric, red spinach, boswellia, pomegranate, amla, ashwagandha, and over 40 herbal and plant extracts and essential oils. We are constantly striving to be at the forefront of innovation. This first-hand knowledge and experience has been vital to us for meeting the market requirement and for staying ahead of the game. We look out into the future in the same way we look into the past, because we believe they are mutually inspiring. Our name, Arjuna, is in fact borrowed from Indian mythology, a glorious hero renowned for his unmatched skills and wholesome devotion to his purpose. The timeless practice of Ayurveda is our rich legacy of knowledge for a better tomorrow. We are both excited and equipped to foray deeper into the world of health and nutrition, fueled by our sense of wonder. This methodical approach of stirring innovation in the world sets the basis for our motto, science of nature.
We hope you have enjoyed that lunch break. Let's now move on to our next speaker. It's our pleasure to have an eminent person to enhance this session. Known for their cutting-edge research in renewable energy, Please welcome Dr. Ulf Schwab to deliver keynote lecture on energy storage system for grid application. With great pleasure, I would like to give a brief introduction on speaker. Dr. Ulf teaches and conducts research in the fields of renewable energy generation, energy storage technology, and electromobility. He studied electrical at the Technical University in Ilmenau and completed an industrial doctorate with Infineon Technologies. He worked as a project manager for the development of power electronic systems until 2012. In the period from 2012 to 2014, he led the Electromobility Research Group at the Tübingen Innovation Center for Mobility and subsequently worked as an executive assistant at ISLE until 2017. In 2018, he was appointed Professor of Power Electronics at the Robert Bosch Center in Berlin, Germany. He also appointed Professor of Renewable Energies and Electromobility at Fulda. Professor Schwab has published more than 60 papers as author in various fields of energy technology and supervised more than 100 scientific qualification theses. His research interests include battery storage technology and intelligent energy management of energy systems. We all rightly welcome sir for delivering this keynote session.
Yeah, thank you very much for this nice introduction. Yeah, I have it here. Yeah. So, now I have a very hard job because it's after lunch break, and it's like in the lecture, the session after the lunch break is more hard than before because the people can slightly fall in sleep. So I try my best to get you back, and I will give you a talk about energy storage systems for grid application. And in my keynote, I will give you an overview about the technologies, about the market, especially about the market, the demands in the world, and at the end, I give you a short impression of some project details we did in our projects in Germany about this. Me? No, I'm too far away. Maybe the battery is? No? I switch it on. It's sleeping. Yeah. Now it works? Yeah, okay, it's perfect, thank you. Yeah. So, okay, now it works, so we can start. Let's have a short overview about the content of my presentation. At first, I want to give you an introduction about my person and my team. I also have here a colleague with me. And then I want to talk about the motivation for research. Let's say innovation and interests. Renewable energy market overview is the next point. Then I want to give you a short introduction to the battery market overview. And then typical applications for battery storage systems. What is, let's say, the development goal for the investigation and versus the market in the future we have to look to. And then I want to give you some exemplary. And last but not least, I will give some words for battery recycling. I put it these slides shortly before the lunch break because I saw here this is many interest in this field. Okay, I come from the University of Applied Science Fulda. This is a university in the middle of Germany. We are located very central. We have more than 9,000 students there, and more than 160 professors, and have different faculties, and I come from the faculty of electrical engineering and information technology. My team consists of these 6 people. They are research assistants and doctoral students, so they do their PhD. And additional, I have about 10 other employees like bachelor or master students. They also work with the research projects we have. What's the motivation for research? Because we do research in different fields, and the fields, they needs to be funded. So it means the interest, it's have to orient to the market. And if we want to have a look, it's a little bit tiny, small. You can see here on the x-axis the interest, and on the y-axis you get the innovation factor, YouTube. Okay, you get the innovation factor. And here, for example, you see this is climate tech, this is future mobility, and this is electrification with renewable energies in the grid. You see there's a large interest, and let's say the innovation are average, because a lot of innovation in these fields are already done, but now we have to put it in the market. And this is a large task for a lot of engineers. And for example, we see another possibility here, the market for AI. AI is now very innovative. You have a lot of different things, they come week by week, and you see that the interest is also here averaged. So I think we have here some leading edge technologies in the renewable energy market and future mobility, and also in the climate. So if you go back then, no. So it means in the end that storage technology, energy efficiency, this is a large market with a high potential, and it's all driven by power electronics. Like we heard before the lunch break, there was the speech about the electric vehicles and also about power electronics. This is a key for electrification vehicles and also a key for the renewable energy net integration. Let's have an overview about the market. The annual financial commitments to the renewable energy market, you can see here, last 10 years, you see that investment in the green energy, here for solar power, increases. So, but it has not this pace. We need to reach the social economic development goals by 2030. So it means it has not the speed to, let's say, reach the climate goals and to have a change in the CO2 emissions at this time. To reach the 1 decrease the scenario, we have to shift more than $1 trillion from the fossil fuels to the renewable energies, because it's a big task we have to solve. We need a lot of money to reconstruct the energy supply. The task we have, and you see here also the real global investment. This is all over the world. You see in which part of renewable energies they will be invest. Here, for example, build up renewable energies, energy efficiency, or efficient transport. You see, this are the main drivers for the change. And if you have a look to the investments to fossil fuels, you will see that investments in fossil fuels are still rise since the last years. Even last year, the large companies invest more and more to extract more fossil fuels, gas, oil, and so on. And you see the renewable market also grows, but it grows not in the speed we need. And if you see and have a look to the different countries of the world, we see that the investment in Asia and Asia Pacific increases the last years very much. Especially is the driver here China. Now you know China is now the main industry and delivery for solar panels and also for solar inverters. And you see they have here 66% of the complete overall world investment in renewable energies. And the market is growing very, very much, and all the other regions of the world have also some advantages from this economic way. But we have also to do this because the CO2 total emissions by region have to be reduced very much. If you see here the way of China the last 20 years, you see the industrialization grows very much, and also with the industrialization also the CO2 emissions they increase rapidly. And here in your country, in India, it's a similar development. I think you are timely a little bit shifted, and if you don't want to switch to new technologies, then also here the CO2 emissions of India will be rise very much in the same way like China. So for this we need you as new young engineers to set up new technologies, because if we want to have a look to the total energy supply and consumption in India, you see that the total energy is made by coal, 44%, oil, gas, so as you can see, almost about 75% made by conventional fossil energy sources. And the consumption is also, it's a industry 40%, then we have here transport and residential, so all this oil is 75% is the consumption in 3 sectors you have to optimize. And the way is not only to change to new sources, the way is to optimize also here the sinks. So it means you have to optimize the industry sector, you have to optimize the transportation sector, for example by electromobility, and you have to also optimize the residential. So these 3 fields needs to be optimized to reach the completely goal. Because India did a very strong commitment in 2022. It sets itself the target to generate half of the electricity from renewable energy by 2030. And these are almost 6 years left, 6.5. And for this it means that you need 450 gigawatts for renewable energy by 2030. But this is a large amount of solar power plants. You did the first step, for example, with this Kerala airport, Kochi, but I think more steps are needed to reach this goal. And if you look a little bit further, for example, in 2040, you need 900 gigawatts, and if you want to reach the climate neutral state, you can reach it in 2070, but for this it's needed to have 7,400 gigawatts. So it's a large number. But I think you are on a good way, because at first you did this decision to 2030, and I think with the help of all engineers in the country and other countries, it can be the truth. And the signs for this change are not bad, because if you want to have a look to the solar module price, this price is falling the last year from September 2020 to September 2023 by about 50%. It's so cheap now to build up some solar power plants. This is amazing. Even in Europe, we have made this experience that solar modules cost half. So we pay, let's say the last price I heard was for a 440 watts module was 60 euros. So let's say 2 years ago, we paid 160 euros. So the market is so large and growing, and this is an opportunity for expansion. So now we saw that the market for the renewable energy sources are changing, and we are in a good way, but now we have to think about storage technologies, because the sun is not shining 24 hours a day. So we need also some storage systems to storage the energy for the night. And for this, I also checked out a little bit the numbers for the changing of the battery pack prices. And if you want to have a look here to the last 10 years, you see the prices for the battery packs. So you see here cells and packs, they are falling. So cells mean you have a single battery, for example, 250, or other cells, 18610, and you see that the prices are falling very much. Even in 1 year, the price was falling by 40%, and also the demand was rising by 50%. Especially with the build-up of new electric cars, the market was rising very much. The price was also falling because they optimized their production, and so you can use some scale effects. And also technical innovations are driven so that the estimation is in the year 2030 you will reach a price of $80 per kilowatt hour. This is a really amazing price. If you compare here, that you see here the average prices are, let's say, about 150. In Germany we have also some projects, and the truth is these prices are mass market prices. If you build up like an energy container, I will show you later on, for example with 1 megawatt hour, this is not big, then you pay between 500 and $1,000 per kilowatt hour. This is the price really for mass market. But it gives also the opportunity for expansion. Let's have a look to battery technology. There are 2 major battery chemistries on the market. You have on the one hand this NMC, it's nickel, manganese, cobalt battery. These are the battery they find in electric. Oftentimes this is highly performant, has high energy density. This is really compact. And the other way, it's lithium iron phosphate, also called LFP batteries. This has a moderate power compared to the NMC battery. So it means you have about 75% of energy density in the same package compared to NMC. And you have another big advantage, the price of the material so it means of lithium iron phosphate batteries, is only 10% of the price of NMC. And this is, I think, a very, very large advantage. And also you have the other advantage, it's security. Lithium iron phosphate batteries are very secure. We heard in the speech before also, after this, a question about burning from batteries and so on. With NMC, it's possible. With lithium iron phosphate battery, the effects of burning of batteries, it's muchly reduced, because you have a lot of iron here, and it needs a lot of energy to heat up iron. And if you also want to build up or set up a battery with NMC, I made here for you a small diagram. You can see the different influence to the different factors of a battery. The three materials, nickel, mangan, and cobalt, have the influence to different parts of the battery. If you want to increase the capacity for battery, you have to put more nickel. If you have to increase the numbers of cycles, you have to put more cobalt. And if you want to increase safety, you put manganese. And this is so that every car manufacturer has, let's say, his own rules, and it's a kind of secret how they combine these different materials to the batteries. But you see that you have a lot of, you cannot do a playing around and can optimize the battery. That you have a battery that it starts with the car. If you have it brand new, then the battery is, let's say, very strong, and it can be very weak after some cycles, or you can also design it that it's a very stable battery. In the end, it depends on the price, because these materials have different price impact of the total battery. And let's have here a look about the capacity of battery systems in the world. Here you see the estimation from 2023 to 2030. Then the estimation says that we want to have 5 times more battery projects. So it means it will be quintuple between now and 2030. And this is a really large, let's say, market exchange or market change in the next years. And also means a lot of batteries are needed for this, and also a lot of materials are. There are three other scenarios we see at the end, that the battery market grows very much. It grows in the same way like the PV market before. And you see that in 2021 we had 9 gigawatts. In 2022 we had already 27 gigawatts. And if you look back, 10 years ago we had just 1 gigawatt in total in the world. So the energy storage market, it's, let's say, like a sleeping giant. So, because now all over the world the people want to put some renewable energy in the market. But for this energy, or this change in the energy and the integration of this renewable, we need a lot of battery support to store the energy all over the day for the night. So it means this is a large field and a large business in the next, let's say, 10, 20, 30 years. What are typical applications in the grid? We have to divide in applications front the meter and we have behind the meter. So front the meter is the electricity generation and distribution, and behind the meter you have the commercial and industry, and also the residential. And there are different use cases in the different fields. In the electricity generation and distribution, you can do price arbitrage, long-term capacity payment, or also some additional services on the market. You can de-risking renewable energy generation. So it's like if you have not a constant supply, you also have to, let's say, have a stable energy system, or also for investment deferral. So these are the things you can do on the market front the meter. And if you want to have a look for the user, they have to do some for the stability of the grid. Behind the meter in the commercial and the industrial, there are the use cases to integrate renewable energy for the self-consumption of the industry, or also for uninterruptible power supply. I think this is very important also in your country. Last night I was reading something, and then it was, I think it was 12:20, and then it was all shut down. So I said, is this normal or no? Then 5 minutes later, it starts again. So then it works 5 minutes, and it was break down again. For this, it's very convenient to have an uninterruptible power supply with a battery storage system. You can also use it for cost optimization, because I don't know about India and Europe, we have the system that you pay not only for the energy consumption, you also pay for the power. And if you have a price, for example, with maximum 100 kilowatt power, and you, let's say, overshoot this for more than 50 minutes once a year, for example, 150 kV, then you step to the max price. It's the same here? It's also the same. Okay. Then this you can also avoid with some battery storage system. So the battery storage system should then step in and should, let's say, remove this peak. It's called peak shaving. And also you can use this for electric vehicle charging, for the infrastructure to, let's say, reduce the peak from the grid, and also to shift, let's say, the energy production from the day to the charging in the night. And in residential, you also can use the battery storage system for the renewable energy integration, especially for self-consumption, or for supplying the EV charging process. Here you see an overview about different charging about different storage technologies, sorry. So the storage size, so it means the power and the discharge time. And you see here, you find batteries as a large part. You have supercapacitors, then you have flywheels, we already heard before the lunch break. And you also have here high power flywheels, but in the end you see the battery storage system is has its home in a large field for a wide power range and also for a wide scalable time duration. No? Ah, yes, no. So, and the applications in the grid are very similar. If you compare here the power and here the time duration, you see the voltage control and frequency control. These are, let's say, major tasks in an electrical power grid. They are in the same, let's say, field and range like batteries feel comfortable. So it also here you can see that battery storage system provides the flexibility for various applications. Now let's come to some projects we set up in our team. Some research projects we did. We have here 2 of them. One is a storage system. It's the project IRENT. It's a 180 battery storage system with a 150 kV fast charging station. So the task is to provide 150 kV fast charging only with 50 kV grid connection. And for the other energy, we have here the internal storage. And the second project is Project ISIL, is a 1 megawatt hour battery storage system for the grid integration and a maximum balancing power of 1 MVA. And this is, let's say, a modular arrangement, and we can scale it to several kilowatt hours. So, for example, 2, 5, 10. It's all in a container. It's a 20 feet container, all in, and we can place it and grid connect and have the energy stores there, and also with energy management system. So, we address the use case as voltage stability, peak shaving, self-consumption, optimization, short-term stock exchange, because in Europe we have an energy stock. I don't know about India. You have something like this? No. We have there, you have to decide which energy you want to build up or you need. Then you buy this on the stock for a price, and you get this for the price. And sometimes it's so you have time where you have a lot of renewable energy flowing in the grid. The price is 0 or negative. There are sometimes you have negative energy prices in Germany. For example, you get paid if you consume energy. This is, for example, on a Sunday. A windy, sunny Sunday, it's a day where we have normally negative energy prices of about -5 euro cents, so it's about 50 ruble per kilowatt hour. You can earn. Then you also do balancing power for stabilize the grid, and security supply, so it means USB. And the advantage is you have more flexibility in the power generation and also in the power grid. You can integrate the renewables very easily without grid expansion, because oftentimes it's the challenge. If you want to put more renewables, you also have to put a new grid, new transformers, new transition lines, and so on. It costs. So at the end, you have to do a decision between the costs of grid expansion and the costs of storage systems. And you do also CO2 emission reduction because you use the renewable energy, and you also can, let's say, reduce the costs for operating the electrical grid. And the main interest in this project for us is the power inverter, so topology investigation. We do a modular approach there that we can scale. The other thing is the battery, so the battery selection, conditioning, monitoring, because we use second life batteries in our system, so the batteries come from the electric vehicles and we put them in a storage system. And then the management of the energy flow in our system. I think now it's time for battery storage, huh? Here you see a battery from a car. It's a car from Mercedes-Benz. It's pure electric car with this battery pack. It's in the bottom of the car. It's made from aluminium, and here the cells are all pasted for a good thermal management. And you have here about 80 kilowatt hours in the system. And the number of cars in Germany in the electric field is growing. Until last year it was growing very much. At the end of the year they stopped the funding, and now the new, let's say, buying numbers little bit decrease, but at the end you see the transformation is still on running. So we have now more than 1 million electric vehicles, and from this, time to time some batteries came back, and these batteries we use for our storage systems. And these batteries are very good in condition, so it has a capacity between 85 and 98%. The power is almost 100%, because these are very good optimized batteries. Remember please this triangular nickel manganese cobalt. This manufacturer uses very good one, and this is, let's say, the basis for our research and our construction. And you see we extract this battery, so we have here the original battery. The battery will be, or the batteries will be removed from the large pack. This is not so easy because they are completely pasted. They have some thermal conductive paste, and this you have to remove. And then the battery packs will be set up in a new box. And here you see one of the boxes we use in our project with the 180 kilowatt fast charging supporter. And here you have also some challenges, because you have to measure the battery conditions, the SOH. Then you have to pre-select the batteries. The interconnection should be done with cells with similar performance. Otherwise, if you have a cell with high performance and a cell with low performance and to interconnect, then the cell with low performance will, let's say, break your complete system. And you need a good battery management system to, let's say, shift the energy between the cells. Here you have a short look about into the system. You have here a connection to the grid, then you have the inverter, and then you have the charging system. So here the system is all AC connected. So the inverter, the charging stations are all AC connected. This is not so efficient, but now there's a change in the system topology. Now the fast charging stations will become DC connected, so that you can reduce one stage, that you can reduce the DC-AC stage. Then you have here on the secondary side of the inverter, the batteries and the battery management system to control the battery and the energy flow. And you see here, this is the state of charge, for example, for over 1 day. And here you see the fast charging capacity. And you see here, if you charge with 150 kV, it's a little bit small, then you can have, well, you have 50 kilowatts from the grid, and 100 kilowatts come directly from the battery storage system. So at the end, you can charge with 150 kV. This is a charging power of, it's enough for, let's say, 90% of the available electric vehicles, and you have, let's say, less stress for your grid. At the end, I just want to give you a just view in the monitoring system of the battery, because this is a little bit different for new batteries. If you have second life batteries, for the monitoring it needs to be to have the electrical operation indicators, the temperature, the state of charge, and then you have to do a battery aging estimation. And the battery has, let's say, only 2 terminals, and from these 2 terminals you can just get the battery voltage and the battery current. And with this information you have to balance the cells in the right way, and you have to estimate the time of charge, and you have to estimate the time of discharge. So this information you can get, then we proceed this information, and in the end you get the aging estimation. This is the calculation from the cell aging by stress and the cell aging by calendaric aging. And this all leads to a SOH. You can get, SOH stands for state of health, and the state of health gives you the information about the actual state of the battery. A new battery has 100% SOH, and you use it in vehicles until you have 80% SOH. If you have less than 80% SOH, you remove the battery from the vehicle normally and put this to the recycling process. And if you have second life batteries, can you please magnify a little bit here on the right? Also this scale, yeah. You see here the first life battery, and here you have second life batteries. You see, then you have, there are some non-linear effects. In second life batteries, the aging will become, let's say, more. And these effects you also have to take into account if you monitor the second life batteries. Come back. Ah, okay. So in the second life batteries, you have to expect the variation in the cell aging because you have not new cells from the same production, you have different cells maybe from different cars, because if you want to build up a container with 1 megawatt hour, it's average 10 to 15 cars you have to use. So you have different batteries, they have different stress level, and this you have to take into account to get an estimation of the cell aging. Then you have to take into account that you have a non-linear aging effects, and then you have a strong influence on temperature. This is very, very difficult to estimate the real behavior of the battery depending on the temperature. And finally, you have differences between the first life operation. You have to take into account into special modules for monitoring SOH and also state of charge. And we did this with some observation methods. Kalman, it's called Kalman filter and extended Kalman filter. This is the most suitable method to do an online estimation of SOH and SOC. This is a PhD work. It will be finished in the middle of this year. So it's very impressive to see here what you can also do with this Kalman filter approach. You can get a really real estimation of the SOH. And this approach also, let's say, can taking into account the phenomenon of nonlinear capacity degradation and also some other temperature effects. So, now some words to battery recycling. This is just a short view because our batteries we use in our containers are batteries from electric vehicles. So I told you they have a capacity between 85 and 98%. So they are, if 98, you ask why they recycle 98%. I can tell you, because the batteries with 98% come from some research cars or some accident cars, and these batteries removed from the cars and built in the, or fit in the containers. And the other batteries, they are more weak, for example, less than 80%. This will be recycled in a new machine, or let's say it's not only a machine, it's a small company. At the beginning, you put the complete battery, complete with package and all. This is the first part, this is the shredding part. So these batteries will be mechanically destroyed completely under some gas that you have no burning effects and so on. Then you have the different materials, they will be dried, and some other chemical stuffs were done, and in the end you separate the materials and you get the black mass. Black mass is the name for the material or the mix of nickel, mangan, cobalt. And you get plastics, then you get aluminium and all these other parts. So this is, let's say, one of the companies that do this. Now in Europe, several companies will set up and will be prepared for the, let's say, for the flood of batteries that come back from the electric vehicles in the next years. And even from the home storage systems and so on, because since the last 5-6 years, the market penetration with battery storage systems in Europe is very high. And let's think a normal average battery storage system has a lifetime of 10 years, and after 10 years you will have a large flood of, let's say, destroyed old batteries. Okay. Then let's summarize. I started with a short introduction, then we got some motivation for research, which are interesting fields, because this is very important. Before you do some research, you have to think about the market for research. But in the end, somebody has to pay for it. Then I gave you an overview about the renewable energy market, the battery storage, and the typical battery storage system applications, and some few about our projects. Thank you for your attention. I'm open now for your questions. Feel free to ask. Yeah. The battery, I think, especially in Europe, we have now new rules, or they set up new rules. They begin, I think, in 2025, that there needs to be a complete recycling system. So you don't want to have waste, and also the automotive manufacturer, they have a look to this and said you need to be recycling more than 90% of the complete battery, because they want to have, let's say, the complete material back, because the material prices over the last years, they increased. So, and if you have a closed recycling system, then you don't need so much new materials. You just need some materials extra to fill it up, what you have lost during the recycling process. So I think the waste is not so the problem. The more large problem, I think, is the energy consumption of the complete system, because you set up the battery, then you recycle the battery, and so on. It's a large energy consumption of the complete process, and it needs, let's say, several years before you get the energy back. Yeah? Okay, can you?
How will you optimize the sizes of the battery depending on the capacity of the, say, power plant? If I have 1 megawatt, 2 megawatt, 3 megawatt, 5 megawatt, say. Yeah. So how are you going to optimize so that you can have reasonable size of battery we can serve for that purpose?
We do simulations for this. That, for example, if you have an industry partner, we do measurements at the industry. We do directly measurements at the grid, and then we see the energy consumption. We see, for example, the peak power days needed. Then we also calculate, for example, energy power plant. We do a complete simulation, like a kind of energy concept before. And with this concept, then we set up the size of the PV system and the size of the storage system. And even in the grid, so the major task is their voltage stability. Then we also see over the time range and the voltage drop. And for this, we can also optimize the energy. Because we have a grid model there, and with the grid model, we can, let's say, simulate the energy we need to pump up the voltage.
Second question for
Yeah?
me. Yeah. What is the possibility if you have a battery which is not fully charged, depending, now, renewable energies depend on the weather, right?
Yeah.
So if it is off-grid system, right, maybe you have 2 or 3 days without good energy from the sun. So this battery might run down. So what is the efficiency of those time when the battery is not fully charged, right? And also what will happen to the lifespan of the battery?
So you mean the total system efficiency?
Yes.
So
when there is a voltage drop in the system that is not able to fully charge the battery.
Yeah.
During on normal days. Right.
So the efficiency of the system is dependent on two different things. On the one hand, it's dependent on the power you have to, if you want to consume, and on the other hand, it's dependent on the power electronics. So the power electronics, for example, with a dual active bridge, is designed to have a wide range with same efficiency. So this means if you have a battery with lower charge, it's not a problem. For the battery, so if you have a battery that have just now 50% of its state of charge, then you have to, with 50% you have also no problem. If you come to 15 to 20% state of charge, you have to reduce the power consumption. Otherwise, the efficiency will drop and also the voltage will drop. But if you know the curve of the energy and the voltage of a lithium battery, and you see if the voltage drops, almost all the energy is gone. So at the end, so the voltage and the efficiency is very stable in the range from 100 to 20%. If you go down to below than 20%, you have to switch off. And then you have also no possibility to do, for example, peak shaving or something like this. And this is a real problem you have in the market. To estimate the battery status. For example, if you want to do self-consumption and you want to do peak shaving. For the peak shaving, you need all times to have, let's say, a safe energy package in the back. And for the self-consumption, you want to use the maximum you produced before. And if you, let's say, if you spend the complete energy for self-consumption, then you have no energy left for the peak shaving. This is a difficult task. Other questions? Yeah.
Hi. So we also did a study on this battery reuse. Yeah. One of the difficulties that we were facing was the daytime power generation and the nighttime consumption of the electricity. Yeah. For major cities, it was quite a big mismatch. So what happened was, when we are planning to design a system, the storage capacity has to be a really huge number to support the night consumption of the electricity. And when you are increasing your storage capacity, the thermal problems that comes with the battery, because ideally when we did the study, it was like, if you are using a storage system, used batteries, you need not discharge less than 40% of the power. Otherwise, you are not getting enough efficiency. And if you are recharging and charging the batteries, again, you run into the problem of a thermal dissipation. You have a lot of problems with the heats and everything. So how did you overcome this problem when you were implementing your battery storage systems?
So our system is cooled. It's a cooled system. So let's say or we start others. Our batteries are batteries from cars. So in car batteries, you have, let's say, high discharge rates. For example, if you accelerate, you have C rates from 5 to 10. So to discharge. If you go to a stationary state, you haven't more than 1 C. Oftentimes you have just 1.5 C rate. So with this low C rate, you never want to run in some thermal problems. On the other hand, we have cooling there. We even switched to air cooling. We had the possibility to do water cooling, but we decided to do in the first step the air cooling due to costs. And if we know or we, let's say, get experience that it's a problem, then we also can switch to water cooling and can overcome the problem. But we discharge our batteries until 20%. And for this, you have to tune sometimes a little bit the current, the discharge current, you have to tune, otherwise the different batteries discharge in different ways, so this we have to set. But the BMS gives us the information to set up the energy sharing.
So we did the simulation with the Indian market in mind, and here the average temperature, that was the height of the temperature that was taken, environmental temperature, was around 50 degrees Celsius. At that point we found the air-cooled systems were not working. It has to be a liquid-cooled system. So we had to reuse the complete liquid-cooled system from the battery side, and then when you compare it with the efficiency that you get out of it, we were running into very poor numbers.
I don't think. If we go to water cooling, I think we can get the same numbers like we have with air cooling in Europe. So because all times you have to think this is a very strong batteries made for car. In the car you have, let's say, the completely spread. The battery is specified to even to drive in India. And for this we have, let's say, a system with the specification, and if you want to use it in a stationary battery stage, you are right, then we have to go to liquid cooling here in India.
Sure, thank you.
Welcome.
Any more questions? Thank you, sir, for that enlightening session. May I invite session chair, Dr. Parvati R., Professor of Electrical Electronics Department, to deliver the oath of thanks.
Good afternoon. We are indeed deeply honored to have Professor Wolf with us for the keynote in the afternoon session. In his keynote, he opened the eye for the need for increasing the innovation at par with the market interest. He also advised the young engineers to come up with smart solutions for reducing the carbon emissions while using renewable energy sources. Thank you for giving an informative session on energy storage in a global perspective. Thank you, sir.
As a token of love and gratitude, we would like to present a certificate to Professor. Sir, please come to receive certificate. Thank you, sir. Let's now move on to our next speaker, Mr. Nishant Unikrishnan, Product Manager and Subject Matter Expert in the Mobility Business Unit at Nest Digital, bringing up 15 years of experience across automotive, embedded and powertrains domains. He graduated with a BTech in Electronics and Communication from Tokachi Institute of Science and Technology. Beginning his career at Bosch, Nishant worked with Powertrain Systems for 7.5 years before transitioning to the role of architect in the automotive BU. We welcome you, sir, to deliver the keynote lecture on the topic Renewable Energy and EV Charging, a clean energy pairing. We also welcome Session Chair Dr. Archana, Head of the Department. Over to you, sir.
The slides.
Good noon, everyone. So, I think my presentation will work quite nicely after Dr. Schwab's presentation. My topic mainly is renewable energy and EV charging. When we talk about EV vehicles or the e-mobility, everyone thinks of it as a green system, a green energy system. But there are many other hidden aspects there which affects our climate negatively. Yeah? So I'm here to talk about that today. I am accompanied with me two of my colleagues, Dr. Sarin, who is a PhD holder in power electronics drives, and Advait, who is a subject matter expert with digital electronic control of the power systems. I belong to Nest Digital. Let me give you a small intro about Nest Digital. So Nest Digital, also called SFO Technologies, we are in business for the last 30 years. We have multiple verticals where we work with automotive, healthcare, business management, infrastructure, industrial management, GIS, a lot of other systems. We have more than 6,000 plus employees, and we work with multiple 500 Fortune plus companies. We are certified for all major certifications across production and different automotive standards. We have multiple patents in our name which we sell across to multiple customers. What you see below are different verticals with Nest. We have technology verticals, we have an education vertical, we even have a food and beverage vertical. One of the key aspects with Nest is product engineering under one roof. So any product that is coming to us, we can take it direct from the concept to the final manufacturing stage. We can even picture in or help the customers in between with specification, engineering, prototype, productizations on another phase. I don't know whether it's visible. These are the snapshots of the design services that we provide. We have a very good power electronics team, a control electronics team, industrial and optic team. And on the software side, we are very well proficient with embedded software, application software, and engineering softwares. Now getting on to the main topic, renewable energy and EV charging. From morning, we all have been talking about e-vehicles, different kind of power converters, how electric vehicle is best suited for the economy right now. But is the real question. Air quality in Indian cities, you guys will have read across in multiple forums, in news and everywhere, that the air quality in India is one of the worst. We have 14 of the 15 most polluted cities in the world. Last time, even during the cricket match with Sri Lanka, the players were unable to continue because of the problems from the smoke pollution. The NOx emissions is 36%, 25% of ppm, that is 10 times the actual permitted rates within the WHO. So we face a very real problem here with respect to the climate pollutions. The ways automotive affects the climate change. Well, the previous generation of automotive, the IC engines, they used to emit a huge amount of smoke. It has your particulate matters, hydrocarbons, nitrogen oxide, carbon monoxide, greenhouse gases, and so on. All this affects our climate adversely. Yeah?
When EV came into picture, it was said that all these things would be reduced drastically, but during the course of the presentation, we will see how much of it has actually been true. These are some figures from India, the amount of emissions from the transportation sector. If you see the road transportation, that is the purple section, that contributes to almost 73% of the complete emissions that we have in India. So if we are able to reduce that, we will be able to improve the climate conditions that we see prevalent in India quite drastically. Back in December 2015, there was a Paris Agreement which was signed by 195 countries to bring down the effect of the climate changes. This was agreed between all the different countries that they will go through different measures to shift to a low emission mobility system so that the greenhouse gases, the pollutions that we have in our systems, the ozone depletion problems, all those could be addressed in a one-shot go. There were defined goals that were set up. So you could see that there were different Euro norms, US norms, even in Bharat, we have Bharat 4, 5, 6 norms, which are for the emissions for these vehicles. All these were set up in this agreement, and it is a continuous plan till 2030 to 2035, where we are supposed to hit the zero emission norms. Some of the measures that were taken was to leverage digital technologies. Previously, all our systems were analog control systems. It was planned if the digital technology can be enhanced further, if the power electronics can be smoothly defined, if the efficiency of the system can be increased, much of our problems can be reduced. Alternate source of energy, renewable energies were given a great push. The renewable energies were supposed to take the front seat as compared to the non-renewable ones. Unfortunately, that didn't happen till now, but we are in a good shape to achieve that. These were the three main aspects that was defined. It's called avoid, shift, and improve. The first two are more or less a discipline that everyone has to follow. It is using public transport, try avoiding private vehicles, go for more public transport kind of systems and everything. You have to shift to an EV kind of system, a low emission system. The fuel sources that we are having, that needs to be made better. Instead of coal, you have to use non-renewable system and so on. The improved part was based on the fuel economy, basic use of renewable fuels and renewable-based electric vehicles. This is a generic style on e-mobility. What does the e-mobility stands for? Any vehicle with an electric motor driven from an electric-based system finds under the e-mobility system. I think from morning a lot of people talked about it, so I would just like to mention the EV infrastructure that is prevalent across multiple countries. You will have a grid distribution service provider, basically a power discom, who is providing energy to your houses. You have fast charger systems which will receive the energy and distribute it to your vehicle. You have the vehicle, and you have a central management system which is a cloud-based network who manages the power flow. Yeah? It manages the power flow, your billing, your payment needs and everything else. So here we will try to see how the CMS and the fast charging and the EV supply infrastructure, how these three can be made more proficient to reduce our carbon footprint and to make our planet a greener one. The pillars of e-mobility, basically the electric vehicles, batteries that Mr. Schwab have already talked about. There are other factors based on manufacturing capacities, power grid and everything, and re-energizing the system. That is the charging infrastructure or the swapping infrastructures for the batteries. This just talks about the general environmental benefits from the EV. Basically, since it's an electric vehicle, there is no tailpipe emission, carbon monoxide poisoning is not there, the global footprints are very low, noise pollutions are lower, you have higher efficiency, performance. Safety is a debatable topic, we all discussed about it. Safety for the e-mobility is coming up. There are a lot of norms that are there in the automotive sector, which try to reduce the harm that is done from a battery. Yeah, you have multiple safety integration levels. We call it SIL, or automotive safety integration levels. So all these battery-based systems, they are given high ASIL levels so that the effect or the chances of a fire or any such incidents can be reduced much further. This is a comparison of EV with your petrol, diesel or CNG-based vehicles. The CO2, I would say it is still almost the same. We will get to know why. But the other gases like CO, carbon monoxide, hydrocarbons, NOx and particulates, those are zero. Yeah? So we have saved over there, but still the CO2 is still affecting our system. That is basically the greenhouse gas. When you see the energy loss of an IC engine, yeah, when you see the fuel tank, when we say it's 100%, by a thumb rule, you will only get 23% efficiency of the complete fuel burned out of the engine. Yeah, that is with par with the best of the engines that we have right now. Yeah, and you have a further loss of 19% while you are going through the drive line. So at the end, you are left with 19% of the complete energy that was stored with your fuel or that was stored in your tank. In the electric vehicle, whereas the motors, you will basically lose around 10%, and in the driveline, you will another lose 14%. These accumulate with respect to the thermal management systems, your losses with respect to harmonic distortions or any other thermal-based dissipations. Yeah? So if you see here, from fuel tank to the wheels, you are getting 19% efficiency, but for an electric vehicle, you are getting 76% efficiency. This in paper looks really, really good. But if we go one step back, if you take it directly from the generation point of view, yeah, from the generation well to tank values that we take, for an IC engine, from the generation, transmission, and plug into the wheels, we are finally getting 23% of the efficiency. This is general statistics figures that were published with your world central organizations. For electric vehicle, the refining processes, electric vehicles it is 23%, and for your IC engine it is 15%. So what we saw previously, a previous case of 76:19 gets reduced to 15% and 23% when we are talking about from wells to wheels. Yeah? So here we are burning some fossil fuel. The 33% generation is burning of the fossil fuel and generating the electricity out of it. There we have a 33, there's basically 67% of loss. Transmission loss is very low, and plug to wheels loss is considerably lower than the IC engine. This is the actual scenario prevalent right now. And this is all because we are using a non-renewable resource or a nuclear resource to generate the power that we are facing these problems. So these are another aspect of the EV vehicles. We call it grid emissions. There are direct, indirect, and grid losses that we incur. Direct losses is when you burn the fossil fuel, you emit certain amount of carbon dioxide, monoxide, and everything, which gives you a harmful emissions. Indirect losses are with respect to your fuel extractions, transmissions, and everything. And direct grid loss is the transmission distribution losses. So these are the three losses that we see. And if you see in India, the car manufacturer side is constant for everyone. The car brands do not distinguish on these side. But the next part where we have the grid direct, indirect losses, these losses differ. For example, in India, the grid direct loss, the India is, if you can read it, India is the topmost one. The grid direct loss is really high because we are dependent on a coal-based source for generating our electricity. Yeah? Whereas if you go to other lands like Iceland, Sweden, and Paraguay, they have different alternative sources of fuels to burn. They have nuclear power plants, nuclear systems to generate the power. This is a similar slide to what Dr. Shaw has shown. This is a split of the power source. So almost 48% of the energy that is generated from India is derived from burning the coal. You have roughly 31% as per the latest statistics in 2024, which is coming from the renewable energies. Renewable energy basically solar, wind power and everything. You have some hydro and diesel gas-based power that forms up the rest. What you see on the right-hand side, electric vehicle emissions. This is for the electric vehicle. So it is said that for the electric vehicle, the CO2 emission per kilometer, yeah, that's the count that is taken for every electric vehicle system to say how much emission per kilometer is actually generated. And if you take it from the burning of the power source to the final efficiency that we are getting from the electric vehicles, India is at one of the worst case standpoints. We are getting at 370, and it is solely because of the coal-based systems that we have. What is the solution? The solution is a simple one. It's a shift towards the renewable energy. Renewable energies can be water, solar, wind, geothermal, or biomass. An argument can be made saying that the renewable energy's efficiency is lower. If you see the solar efficiency of the panels that we get, the actual energy efficiency to the converted power that we are getting, it is poor. But still, the energy being locally generated at free of cost value, yeah, it prohibits the emission losses. It provides you a cleaner fuel and a greener fuel. This is the latest concept that everyone is talking about, renewable energy electric vehicles. Basically, you are pairing your electric vehicle with your solar panels. You charge your vehicle with the solar energy during your home time, office time. It is just plugged into the network. The battery takes in the power. This battery power can be retransmitted back to the grid in the times of need. Yeah? There are a few challenges for this. As we discussed during the very first section, the bidirectionality of it, control from the grid side, how much of the grid needs to be modified to accept this much power. All those things are big, big challenges, but that is something that is worth investing if we have to have a greener earth tomorrow. This is the share of renewables in the transportation. Right now in India, 97% of the vehicles are IC engines. Yeah, it can be petrol or diesel. A small amount of CNG vehicles are there on road. Only 3% is running on renewable resources. We have only 3% worth of electric vehicles on road right now. There's an increasing trend in the renewable energy format. If you see from 2013 to 2019, the solar PVs, they were on a huge rise. After 2019, during the COVID time, it reduced a bit, but fortunately we are on path to having a much bigger rise on the solar panel sides. The wind power is, I would say, till 2015, we were investing heavily on it. At 2019, again, we ran into certain problems with the wind-based systems, so that is on the low drop, but India has started investing in the maritime windmills. These will be situated on the coast, and that will generate much more energy. So that is something that we are working on. Hydropower is something that is requiring a huge amount of investment. You have to build dams, you have to build a different complete setup to generate the power. So that is a slow rising system. Biomass is always there with India, but unfortunately it is too complicated to make it profitable. This is the solar EV charging. You basically have solar panels at your office, malls, at homes. You install them on top of your building and you just plug in your vehicle. Yeah? Whatever solar energy, let it be with a 10% efficiency or 50% efficiency, whatever power that you're getting, that is free of charge. All those powers are stored in the vehicle, and at a later point of time, when needed, this power can be extracted from the vehicle side. For this, a lot of challenges were there. Cost of solar panel, this, as we had discussed, the cost of solar panels has reduced drastically. The lifetime of solar panels is another thing. We have the polymerized solar panels, which has the lifespan of 20 years or so. Previously, this was lagging at 5 years, 10 years, where we were not able to make it beneficial enough for the amount that we are spending to be recuperated. So all those points are now in a right path, and we are in a good way to get into a solar-based EV charging system. There are some other energy initiatives, managed charging, network charging. I think Dr. Schwab already spoke about discount at time of peak renewable energy, the negative billing that he was talking about. Now there are still some challenges with renewable energy. The power fluctuations, you know that you cannot depend on renewable energy 100% of the time. You may be thinking that you are going to generate 3 kilowatt or 4 kilowatt of power, and with a climate shift or with a rainy day, all these calculations will be going for a loss. The growing challenges in managing the production of and consumption of the fluctuations, balancing between electric supply and demand. I was asking this question earlier. The daytime energy generation and the nighttime consumption, especially in developing countries, are having a huge difference. Or places where the climate is extremes, hotter climates, everyone is at home, everyone is using an air condition, and so the power consumption differences is much huge there. This topic we already discussed. I will just run through it shortly. This is the future of electric batteries. What all are the upcoming trends with batteries? Batteries form a major component of your electric vehicle. If you see the cost of an electric vehicle, 35 to 40% of the cost of an electric vehicle goes to the battery. So if you are spending that much amount of money, you would like to have that component to have a very huge life. But as of now, we are failing on there. What are the major challenges? Can better materials be found? Materials with high energy density, lower cost, better strengths, materials that will have a bigger lifetime, components that can have better densities where you can have multiple charging cycles. These are some of the aspects that people around the world are currently focusing on. And finally, of course, the battery disposal. The lithium ion, we can reuse it to a certain extent, but still there is a huge amount of loss that happens for the treatment, for the waste management and the disposals. The future of the EV batteries, they basically are split into 3 different categories. One is the electrolyte that is used within the battery. Second is the anode that is used. And third is the battery cell material itself. So some of the components are solid state batteries where the lithium ion electrolyte is replaced with a solid material. This basically reduces the thermal management impact, catching fire of the batteries and all those things. Fluoride ion batteries, basically the electrolyte is replaced with a fluoride tetraelectride. This has a higher energy density, so you are able to store more energy with the same amount of space. Lithium titrate anode and silicon anode basically are newer anode technologies where you have higher density, more recharge cycles. Your anode, your graphene coated copper anode, those will deteriorate over time when you are recharging the batteries multiple times. So with newer anode technologies, that will be at a better rate. Nanomaterials, specifically graphene in battery cells. Graphene is a high tensile strength device, better electrical density, better electrical capacity, lesser thermal deficiency. So all those points that the graphene is more suitable to be used in battery cells, which is being exploited right now. And phosphorus encapsulated nanotubes for having a system with more recharge cycles. Right now, the battery recharge cycles, we say 100,000 or 150,000 times. But these systems will take it to 3 times or 4 times that capacity value. Battery disposal, we are told 2 mechanisms. One is reuse and one is recycle. Reuse, what we told is the second string batteries. So right now with the industry, the battery capacity, which is 100% when you are buying your vehicle, reduces to something around 80% after 5 years of use, which is a huge difference if you are driving your vehicle. Yeah. So this second-rate batteries, they are reused for multiple purposes. They can be energy storage, they can be for your home charging, home battery usage. It can be used even for the DC chargers where you can store the battery or recuperate at a certain point of time. The recycling, basically, as he has already explained, we recycle the batteries to retrieve out certain materials like aluminum, lithium if possible, and certain other phosphorus components that can be extracted back from the battery and can be reused to create new batteries. This figure shows one of the electric batteries under different usages. You have the reused batteries for generators. The batteries can be kept as a backup for the generators, for your battery management systems or your BEMS. You can reuse all those solar old batteries to consolidate and store the power. I have the same points, power peak shaving, regulation, reactive powers, transmission stabilizations that was previously discussed. These are the reported lifespans of the battery under different conditions. These were just simulation results to see how far the battery deteriorate under different conditions. So what was estimated was, as an energy storage system, we can have the battery till another 10 years of usage. For fast EV charging, it can be used for another 30 years. Home energy storage with multiple charging and discharging patterns, it can be used for 12 years and so on. Talking very specifically about India, we have a lot of challenges with the e-mobility segments in India. With our government structures, how these EV segments is distributed across multiple departments, it is really difficult to get things moving to achieve your goals with respect to your complete e-mobility infrastructure. Capital cost for raw materials is really high. The EV charging infrastructure is very rudimentary in India. The number of charging stations that are available are very low as compared to other developed countries. Battery costs are really high. As I said, we are in India, the batteries are primarily imported for the reason for cost. In India, the manufacturing cost for batteries would be really high. If you are buying an Indian-made battery, your system will be as high as 60% of the vehicle cost will be the battery alone. There are other challenges with respect to the power structure. In India, we are already in a power deficient state. The power that we are generating with our 1.4 billion population, we are consuming more than that. Yeah. So the power deficiency is a very big factor in India. And then on top of it, to charge on a new EV vehicle, having the capacity to generate that much more energy becomes really difficult. Safety is another aspect, the safety part of the battery side. With the climate that is there in India, with basically the hotter climate, is a huge challenge. You have seen videos where vehicles were catching fire. A part of it was caused due to the bad materials that were used in the vehicles. Another part that was because of the climatic condition there. The temperature that was there was really high to start with. So that all added to the impact, and we had a very bad system there. So I will finish with this. India has a huge potential with the EV domain. It can really help us go towards a greener and a cleaner future. But for that, we need to put in a lot of effort. We need to make sure that the systems that are on the back end of the EV vehicles that are functioning properly. We need to have a cleaner car from cradle to grave. So even the production of the vehicles to the end usage all has to be in a green system. I think that was all from my end. I'm open to questions if anyone has any.
Any queries?
Thank you then. Thank you everyone.
Thank you, sir. Thank you for that enlightening session. It's my pleasure to invite Section Chair Dr. Archana R., Head of the Department, to deliver the vote of thanks. Ma'am, please.
Thank you, Ringo. Now here we have Mr. Nishant Onnikrishnan From NEST, he has delivered a keynote address on renewable energy and EV charging, a clean energy pairing. And starting from the requirement for renewable energy in electric vehicles and the challenges in the field, especially regarding the Indian perspective, he has explained all the points very clearly, and also he has emphasized the Government of India's aim to become self-sufficient in energy based on renewable energy by 2040. Thank you very much, sir, for your valuable keynote session. Thank you.
As a token of our love and gratitude, we would like to present a certificate to Mr. Nishanand Krishnan. Ma'am, please do the honor. Sir, please come forward to his certificate. Thank you, sir. Now that we have gained insights from our speakers, with this, we wind up the keynote lecture sessions today. Parallel online paper presentation sessions and offline presentation session will be held in conference room TB 407 and IEDC room. Thank you all.